Man. Phew. Hello, ladies and gentlemen. My name is Rockwell, and today we're going to be designing a system for, well, I should open up IDE. So the point is like to design a first $1,000 business or something. So that would be insanely effective or something. Right. Or something like that. Yeah. So what we will be doing is pretty much like I said, we would be designing, Oh, shouldn't have. I saw the message from my girlfriend in the morning. Ha. But if you come back to work again, all right, because like relationships hardly matter when it comes to money. All right, and yeah, I think I should open up Obsidian and show you guys. Like, yeah, we have successfully. This today is at day 10, so not 9 actually, day 10. All right, and not day 19. What the fuck I'm doing? Day 10. All right, and we've successfully made $0. I mean, we still haven't got like a single penny, which is like a kind of disappointing, and I know. And this is gonna be like the first SaaS business, like okay, you shouldn't have like a look at that, but yeah, that was like analysis of my expert, um, compared to my current girlfriend or something. But yeah, and well, yeah, we have no explanation. We have like a reality map, and then we have like thinking in systems or something, right? So we have stuff like that. We were supposed to read this, but we're gonna read it tomorrow, right? Today, what we're gonna do is like we're gonna be um you know building an architecture for our SaaS business, right? So first of all, I think like I need to actually build an idea or a rough idea of the front end is gonna be like a rough image or something. Maybe I can design maybe in the design I can design like a rough an outline because like it's kind of getting hard. Like draw with just my hands, right? Something what's gonna be there on the app or platform. First of all, we'll have like a connector. So like this is like okay, you open up like a okay, my drawings kind of suck, so that's like another problem we have there. But you open up like, and okay, let me just a couple of checks out a couple of things first, and yeah, there's a lot of light. Let me just decrease some lighting. Well, that kind of gives like my face a black gesture or something, but that's all right because we can fix that. So, all right, so where are we? Right, let me just then close the entire thing because like yeah. So the thing is, or the main point is like, let me just go back to drawing that for you guys. All right. So this is our phone or application or something like that. And phone application, I think at the top we should have like maybe something like this goes like connector or something connector here. So yeah, you tap on the button and like this is the phone. You guys can pretty much imagine like this is phone or something, right? Doesn't look like a phone. I know fucking looks ugly, but you can say like connector. And so connector, what is connected? It takes photos. Takes photos, right? Take photo, or you can have like a something that says upload the photos of the AC. So what this simple system does is like you can tell it like the connector the model of the AC that you have, like model of the AC, right? And then it kind of like as soon as you connect, it kind of like shows like here the remote of the AC or something. It kind of like does an analysis and kind of like pretty much detects which AC you have and allows you to connect through a Wi-Fi. So it asks for permissions, right? Permissions. Permissions. What are the necessary permissions? I think we need ChatGPT here to kind of like analyze that kind of stuff because, of course, definitely I do not do that, and I think we need how I hit my 20K. I don't really care about that, but he just commit suicide. Okay. Then we need like because we do need to design a lot of stuff. So how do ChatGPT, I had these AC remote controller that I found on Play Store, and these apps were like they can connect with any AC, like not all the AC with the like window AC, and there of course a lot of different variety of ACs they cannot connect with, but there's like the normal AC that we have on the wall, they can pretty much connect with that. So I just want you to tell me is like like what I want you to tell me is like how these apps are so able to connect with the AC or something, right? Like I don't get it. Like do they use it the Wi-Fi or like what are they actually using or having to connect? Just tell me the simple things or the structure mechanisms that they are using or something to successfully detect what AC it is and like how to connect it. Like you have to manually input the brand or something of the AC and it takes time for the system to know. Right. And there are multiple, like, they have to, like, yeah, but I still tried one app, didn't successfully connect it with my AC. I don't know why. Maybe because this AC didn't support random connection. But yeah. So yeah, let's just see what goes. Most of your app works in three ways, which is when used depending on both your phone. Infrared. Okay, we do not have these in phone. Infrared blaster. IR, the most common method, which is kind of like let the flashes in infralight. The AC has an infralight receiver that detects those flashes. Those flashes in the binary, something like this. This pattern might mean turn on, set temperature this, when high, swing mode on. Oh, the Xiaomi Redmi, however, has info on top. App simply turns your phone into a remote. Why do you select your AC? Own codes. Ah, brand A, it's that. The app contains a huge databases of these codes. When you choose your brand, it's showing to different code sets. When it asks, did your AC turn on? It's basically saying, does this code work? No, let's try the next one. Wi-Fi smart AC. Some modern AC have a built-in Wi-Fi. Ah, this is why some AC app lets you control your AC from another city. These apps don't need AirBlast because they are communicating digitally over the network. Usually you pay once and you control it locally. IR Blaster, a lot of modern phones removed it. The app doesn't have your AC code base. And brand use unusual protocols. Your AC only supports its queue into their ecosystem. Your AC model protocol than other models from some brands. One IR goes light. No, I didn't use IR when it mostly doing is for each possible code send code. Your other feedback market, the app doesn't magically know which AC you have. It just brute force through a library of known remote controls until one works. No, I'm trying to what you want me to inform with. I'm trying to build a company. All right. So okay, I get it. Like that's why the app asks for the feedback if they work or not, because the app itself would never know, like which is gonna work. So how about we change the system and about like because I think every product has its own like every company because like I had a like AC like wall mounted AC. I don't know what is normal AC and split AC, but this AC is made up of like company by Dakin, like if I'm pronouncing it right, they made it right, and I selected like Dakin, like and they had a nine option, like nine different sets. I mean, for database, I guess I passed through all of them. It didn't get selected. So what I'm trying to build the exact same app they built, but with far much more efficiency. So I thought maybe I can create a system where I could just take photo of the AC, right? And the app would able to detect which code set is related to it. Like, is that even something like like what which like because it sends codes, right? And I didn't use the IR blaster or anything because I do want the AC to get connected without the IR blaster, right? And another thing is like they install the app, and as soon as a person takes takes photo of the AC, we can already know that if the AC has the features that we want, right? This is like one of the most important thing in my app because my app is like autonomous temperature controller in which remote itself automatically control the AC on the basis of outside temperature, environment, or something like that. So you never have to control your AC. So that works in the background always, right, when you're in your room. But that's the another feature. The first feature is to even know which AC works with those features and which ACs don't, and how do you quickly detect and let know the consumer that this is going to work out or not. That is the main thing. So like yeah, I'm trying to design something like that. Might even support Wi-Fi. A photo can contain that information. Take photo, computer vision detects brand icon, model number, sticker, manufacturing year. But yes or no, smart features. This is feasible. The hard part is the AI. The hard part is building the database. It's a P phone, Wi-Fi, AC. Yeah, VR control your smart ACs. IR only ACs, you need hardware somewhere. And emits IR signal. So we can also target IR only AC. So we can like they can get an app and like IR, and then like that kind of like tries to, if we are making a business out of it, we can get in a partnership with a small company that produces IR hubs or something. Right, but that's for a lot in the future. Your photo idea can become a compatible. Instead of taking a photo, we'll know exactly how to control your promise. Take a photo, and we'll tell you whether your AC is compatible with the features that are available. That promise is much easier to fulfill. I would design it like this. Take a photo of the AC, extract brand, model, serial number, cloud database lookup, output compatibility 95, connection at night, features auto, like yeah, auto temperature control, sleep optimization, energy saving mode. Like yeah, now here's the question I do. Why should this be an app only company? The moment you want to control millions of old IR only AC automatically, you almost immediately push towards selling a seat with the Wi-Fi IR hub. Otherwise, you're limiting yourself only to smart AC owners, which is much more market than the entire installed base of air conditioners. Ah, all you need is a fucking IR in between that doesn't cost much, and then you can have like a system that could. Ah, man, let's make this $1 million business. This is my first $1 million business. Who said it was 1,000? Let's control. Let's like there's millions of people. Okay, it's like they can buy another services from ourselves. It's like a controller. So all they have to do is like they have to buy like 1,000 like from our websites or something. We can get that product on Amazon. We just need an IR hub. I just need to buy one myself. Know if it works or not. Actually, drop ship the IR hub. Drop shipping, yeah, we are gonna drop ship it on Amazon. We are gonna buy it at a use case and maybe add like 120 rupees or something extra to it. Shape it for ourselves. Maybe create a local area where we can like rent a local area where we can get the products and sell it to customers or something, and then automate the entire business so it earns millions of dollars without me even have to think about it. Damn, we're doing it. We are doing it. We are fucking doing it. But for I think you do much. Imagine imagine people just only have to spend about $1,000. Sorry, about 1,000 rupees, which is about like an installation power or something. Like if they have that, even that is like too much. If they buy an AC worth 30 or 50,000, if they are as poor as fuck and they're buying all IR ACs, like then like yeah, but we can control the smart ACs first to generate the revenue to get started with the poor AC. I think like yeah. So we can scale. We can scale. It solves the scaling problem by itself by targeting the premium people or like the market. But how do I connect? How do I connect, babe? This is the $1,000,000 question, guys. This is the $1,000,000 question. How do I connect? Right, I'm changing my internet. It would get bad for 1 second. No, it didn't got bad for 1 second because I had literally the same router, I guess. Right, why should this app be an app-only company? The reason why at the starting phase it should be app-only company because I need revenue to produce my own IR hub. Right. This is what you call it, right? IR. So small IR hub. So that's one thing. And I can like ask them to buy them from local markets too, but it's really better to have your own product and then ask. And another thing is like I only right now I do not have like um I need to first start creating a revenue by actually using smart AC. But the problem is that I do not have a smart AC at my home, or do I? Like, what are the smart ACs? Let me just check on Amazon. Wait a sec. We need to go on Amazon and we need to go like, is my AC? I think my AC is IR only AC. Starts with 4th July. What is that? 4th of July, they have Amazon Prime. Oh, yeah, I need to buy Keratin. Not Centrum. What is Centrum? What? Salmon. I don't know. Slow multi omega for multivitamin, NAC, multivitamin minerals. Well, who the fuck cares? Right, so we just need what we were asking, like yeah, smart AC. So like I don't think so. Like the AC here is 3 to 4 or like no years old. Like yeah, man. The problem with my AC, it's like it's 5 to 6 years old. I mean, or even older than that. What? How old is my room's AC is? I need to ask my dad. All right. I mean, and I should tell him about the idea that I'm building. That's why I should actually shift this into the hall and put the hall AC in my so that I can constantly check whether it's working. LG Essential Series to the Star Smart Split AC. Like okay, you call them split. I don't know why. Smart Inventor Copper. I don't know what that is, but who cares? I don't have to build those stuff. 1 cent 3 star. This is 3 star. This is 2 star. This is 3 star. I don't know. This is 5 star. 48. 31,000. Okay, this is Amazon choice. Split AC. And they have Wi-Fi. Okay, what my AC is, I don't know. Like I need to like we do need to have like a databases of AC, but how do we get a database of AC, right? Winner BIT awards for best in customer service, like 6 and technology, KV display, carrier, 5 years warranty, Smart Connect. So it has Smart Connect. Oh, they have their own ecosystems too. But I mean, do they support IR? So like, does the smart AC supports IR? Then we can actually target even those ACs that don't want to be part of our ecosystem. Fuck them, because what we'll be doing is like, even if some AC, even if they're like, yeah, first we'll start, of course, only the smart ACs that can allow us to. What was the noise? Came from the outside. So we can like, yeah, but IR sensors. Yeah, they're fucking cheap. They're fucking cheap. You can just get one IR sensor. Like, yeah, you can get a set of two. I mean, they're selling it for cheap. I think we can get it from a local producer. Oh yeah, that's my mom cooking something. I thought like yeah, where it was coming. Like yeah, you can get them from like yeah, for really cheap, and especially if you're buying them in bulk. So you can get a local producer who are actually producing that or something, maybe from like Delhi or something, which is not a big thing, and like a huge yeah, and then you can create your own product. Right, if you experiment out with it, like you can create your own sensor, like yeah, maybe something like a small hub, like something like that, which costs 500, which is aesthetically pleasing. So you can have your own manufacturing, right? Yeah, never thought I will get into manufacturing industry for this business, but this is how businesses happen. People start from scratch, build hundreds of things to just fix one problem, and earns millions, right? But okay, first of all, we're gonna target this as a company that not just control your temperatures but saves money. People wants to save money, so that's why a couple hundred, let's say, like, yeah, this is Amazon choice, this is like 150, so you can get two sets for 150, right? So so if you can get two, that means you can produce like one hub for about like 500 rupees within a five, because if you have a packaging or small hub like that, and then a phone connects to that small hub. So if you had a connected to there, so it's like I don't know how much that costing would be, but that costing would be somewhere around 500 rupees, and 500 rupees is kind of cheap. That's like about not even $5. No, sorry, not even $7, right? So somewhere about that price, so you can get that, and with that thing, you can actually save a lot of money. So if you are buying, let's say, even an average, like, because how many people have bought this kind of, like, they've bought about, like, yeah, it's 600, like, yeah, so about a couple thousand people have bought this AC or something, right? So, like, yeah, any brand, anything, window AC, up AC, X AC, Y AC, Z AC, every AC, like, oh, but do every ACs have IR sensors? That's the biggest bottleneck. ChatGPT, do every AC has a IR sensor? And yeah, you're definitely right. We can make, but first of all, I'm gonna start targeting the like smart AC and use them to actually see and check if everything functions, and then I'll scale with my own product, which kind of like scans the, like, with the IR sensor that comes with the apps. It's like, yeah, the app would redirect them to an Amazon page. The Amazon page would have our product. They will just simply buy the product, get it their home, place it in the room, and now even if they have like, yeah, the product should cost about a couple hundred rupees, not much, because it's just at the end of the day one IR sensor, right, and attached, like, which simultaneously connects with your phone with a Bluetooth or something. So it shouldn't cost much, like somewhere of 500 rupees to like 1,000 between that, or the cheaper it is, the better. So I'm gonna make it cheaper, right? So we can have that hub placed in the room, so it autonomously changes the room temperature, at the same time saves electricity. But the biggest problem is, like, do every AC, even the smart ones, have IR thing? Because if smart ones have IR thing, then that's actually a really what do you say, a really good thing or something, because, like, yeah, it saves us a lot of problem, right? Because then, like, what we can do is, like, we can simultaneously, because let's say in a room there's a smart AC and a normal AC, you can connect to them, both of them simultaneously, by using an IR only AC, right? But I want to know, like, yeah, what, like, yeah, because at the end of the day, what IR does is, like, it sends signal, right? Like, could you explain me the entire system? Actually, I'm confused about a couple of stuff. But remember, at the start, I'm only gonna target smart ACs, not because, like, it's because, like, creating like, your own not specifically your own manufacturing, which what you will be doing is you buying stuff and just building them together to build a product. So it's not your own manufacturing, but assemble, right? You need to still assemble the things, and then you need to still upload them on Amazon or somewhere for the other people to buy. And you see what I'm trying to say, guys? Like, yeah, it will take a lot of time. That's why, like, I need to start with smart AC and start testing it and start targeting rich customers at first, because, like, a lot of rich people, and they would be willing to spend a lot, like, a couple dollars a month or maybe a year for the service or something. So yeah. Ah. That's why we need a sensor, right? So you can just pretty much take a photo, and the customer can know whether this fucking bullshit AC has certain specific things or not. Right. Oh my gosh. I think it will take a year to build this. Right. It can take as long as up to a year. But man, this is $1 million business. This is not like you can have hundreds of thousand, and then the best part about this business is that you can scale it globally. Right. So what I mean is that, like, especially with a lot of ACs, you can scale it like globally or something. So you can have like that one product sale globally, right? And yeah, it will become a lot easier to actually, like, yeah. Damn, you can make it work globally. It can be a global business because it's like it can be scaled. So this is gonna be my first. I don't think so. It's gonna be $1 billion business, but I think it can reach effectively if it's scaled globally. It can reach about hundreds of millions. All right, in revenue in a year. No, it cannot reach that much. Okay, it cannot reach that much. How many people have AC in India, and globally, how many people use AC daily? We need that, like, usage by 2026. 560, 27 million people, 374 million people. If these people just give me $1 a month for my service, that's $12 a year, and oh my gosh, that is like $1 billion business, if not a million. And this is just like in the past, you don't know, like in the entire, this is just alone in like India, there's 27 million. In China, like there's 500, like, oh my gosh, I'm targeting a really big industry. 148 million people, 12 million, 3 million air conditioning. Like, yeah, you cannot know the entire, we do not know the Russia, we do not know the entire globe, but world population review, but we do know a couple of things, which is more than enough for us to know. Like 1 million is 10 lakh. That means 1.6 crore people in Mexico use AC on the daily basis. Man, it's a really, really big business. 6 country most AC units. The most like, this is like China. We need to target China. Oh my gosh, we need to target China, but I think they don't allow different businesses to come to part of their economy. I don't know. We need to target United States, Japan, South Korea, India, Brazil. We need to target all these companies. All right, so this is going to be my first startup, I suppose, which is going to give us enough money for our investing company to actually start and rocket off. Like, yeah, then after that, I'm going to build an investing company. That's for the future, though. Okay, our major, like, yeah, we'll start with India, scale it all the way to China first. Like, fuck United States and Japan. Like, yeah, and because, like, yeah, I think United States and China are the biggest businesses that we have to, like, we have to create like entire different platforms for them. And after that, and soon enough, like once I got with the smart AC, I think I need to hire a team. No, I don't need to hire a team. I just need to hire some Chinese people to know some basic stuff that knows English, right? About the AC conditioner or something, like, yeah, something in that. So, and a lot of information gathering can simply be done by AI. Literally, fuck, fuck teams. We're gonna build 100 million, if not $1 billion industry or a $1 billion company. By an AI, and by myself. Yeah, vibe coding it. Yeah. Yeah. If that works out, then fuck. Okay. Yeah. Let's build it. Let's build it no matter what. Usually, and this is enough data for us to know there are enough customers. That's it. This is all, and this is like if you are trying to scale it globally, that's like a bigger, like I can hire the teams to transform the language into like, yeah. As soon as you start scaling globally, then we need a really good, like at the start, it's not gonna be the best. The infrastructure, like the front end is not gonna be the best. Everything's not gonna be the best. Just working earns money, and if that earns money, we can scale it. Like fuck, we can scale it. I mean, we can go with smart ACs, and as you can see with the smart ACs too, we can have like just in India. This is like we can like go with the smart AC babes. Smart AC. I got the spelling of smart wrong. SMART, smart AC. It's not so like you have like a 3K just about in the past month. You have like 800. You have like 300, and I think these people would be willing to pay about 90 rupees, right, per month, right, for the AC and autonomous, because it saves a lot of like even if not 90, let's say you can have it like for 10 or 20. Like, yeah, just a small amount of money works a lot, right? Just 10, 20 a month. So in a year, we can charge about, let's say 10 a month, let's say 120 rupees a year. That's literally nothing. That's literally, but now you have 1,000 customers that are paying you 120. Like, okay, let's go to calculator. Calculator. I mean, I think I should pay less focused attention on the money part, because I think that's what, yeah, like this pricing, like, yeah, what 120 multiply by 1,000. So like that would be like what you will earn in a year. But of course, there's no 1,000 customers. I think if you just multiply that by another 10, that's like 12 lakhs. Like, yeah, this is like, yeah. So if you are targeting 10,000 customers with a smart AC, because like, of course, 10,000 customers are, because like 3K in just 1 month, right? So we have just in India alone, you can easily target 10,000 customers. But then again, we're gonna shift our market and pivot it, because the number, we are not targeting just like 1,000 or 10,000. Even as long as we get the 10,000, I think that's when the business would actually explode in capital. But we need to target millions. 10,000 is not enough. We need not 1 lakh, but we need hundreds of millions of people to actually start to pay, like, yeah, just $1 a year. That is more than enough for us. Like, yeah, $1 is like, in terms of, and if you give $1 and it saves you $100, not $100, let's just say $50 or $40, that is more than enough to pay, right? Yeah. Targeting something that millions of people use, I suppose. I get it now. That's how you scale businesses, right? Usually use smart two communications are phone, Wi-Fi, AC, and remote IR/AC. The micro listens to both. Think of it as like TV that can control by a physical remote, buttons on TV, and an app. Different input, same brain. What exactly do IR do? IR is just a way of carrying info. Imagine you press a temperature. The remote doesn't send increase. Many remotes actually send the entire state. The remote converts this into a binary. The AI sees the flashes and reconstructs the data. This is actually very good news for your company, because if your AC already has info, your hub doesn't need to touch the AC physically. You can simply paste it in the room, your app, Wi-Fi, IR hub. Work. One correction though, 1 hour. But how do you send signal from the phone to an IR transmitter? Right? You have IR sensors that they sense, right? And then you have like a IR transmitter. Infrared blaster receiver. Even this fucking product, like, yeah, so you can use your phone as an AC or something. Oh, so this receives it? I think I've got the spelling of transmitter wrong. No, transmitter. But incredibly, the receiver is optional, but incredibly. I do not need to know how to remotes. I need to get a YouTube video quickly. YouTube.com. I need to get a quickly video of how these transmitters, these stuff like that functions. This is another thing that you can understand from this situation, is that you do not need to know on everything. You just need to know a thing about how a business function, how something function, like how there's a pain. You just need to know pain. How you need to know now you need to learn everything you need to know in order to reduce that pain, and then you create a product out of that pain, and then you scale the pain, and then you make billions, if not millions, right? That's how companies functions. Like, not knowing information was a pain even before people realized it. But yeah, so what? What I need to find, how to remote. I think there is some like remote functions. I think I should ask ChatGPT, like the most asymmetric videos. ChatGPT, could you find one YouTube video online that can actually tell me how AC remotes and like TV remotes function, like the entire explanation, right? Like of how the architecture behind that thing functions, like a real architecture, not just like how there's an IR transmitter, how there's a receiver, how does the remote sense the signal or stuff like that. Like, yeah, every part of that detail, especially about the remotes and how like ATV and controllers like grab those information. Chopray, not Chopray. It does always. Whenever I said ChatGPT, I think maybe because it's considered me English, or now it's gonna find and do the job for me. Key matrix scan, remote microcontroller protocol.
Hey, my name is John Broadwell, creator of the Serial Wombat open source project and a consultant in my company, Broadwell Consulting Inc. If you need help with a project, hit me up. Today we're going to be talking about the NEC infrared transmission protocol from a protocol perspective, which may be interesting to people who are interested in implementing it in their own system, or have an academic interest in this. If you just want to be able to read or send infrared, there are a variety of Arduino libraries, and we'll be looking at the Serial Wombat REMCON board, which integrates all the hardware that you need into an I2C compatible board.
I see. So every different company has a different. Ah, man, this is an expensive problem to solve. Trust me, this is an expensive problem to solve. You just can't solve it in 30 days. We'll take a year. We'll take a year to solve this
This
problem.
video does not talk about the details of how to use the Serial Wombat library to drive this board. We're going to be talking about the technical details of NEC. So if you're interested in IR transmit and receive, I would definitely recommend.
I think because what we are trying to build here, what we are trying to build is like like the thing that we are trying to build is like someone can just take their phone and put it down once they've connected to the IR hub, and they have the app installed that is running in the background, and that's it. Now they literally never have to. Like, we can also add a small camera that comes with our IR hub, which can place to the corner or the top of the room, which kind of like detects every signal sent by the room, like within a certain specific radius. So it can not just know, like it can also know how many people are there in the room, right? So it can the size of the room, everything. So now what you've done, like once that is done, like it will take at least a couple of iterations for the starting 1 or 2 weeks, but after that you would literally never have to change your room temperature at all. Literally. Yeah, duh, right? So it can, so if you have a camera, it can also make predictions about your body size, and oh yeah, we can, yeah, man, it's all mathematics and like, yeah, something like that. But I'm able to build that using an AI because AI does the mathematic for me. I just need to know the systems and what system is doing what kind of like stuff. Yeah.
Serial Wombat 8B REMCON board.
So now, if you have like multiple people in a room, then what you need is like we need an IBT. So what does IBT does? It's like it calculates the ideal body temperature for every person within a room. So if you have a sensor or a camera, what it does is try to approximately find out their age, weight, and stuff like that. But it would be far much better if they say it. But if you have an auditorium and you have 100 people, then it makes 100 of examples, approx examples. Some are wrong, some are right, some are above the average, some are below the average, which kind of cancel out itself. You can see. So now you have 100 people in an auditorium. It gets, oh, there's 100 people. There's this much size. So that means according to laws of physics, this much how much coldness would be. This is the environment outside, and the auditorium is like, yeah, so this is how much time it would take for the outside to get colder enough or something, and this is the power of the ACs that I have. So it's like, yeah, you're scaling the system. First you build a system from one AC, then two AC, like, yeah, it's scaling from the ground up or something. So first of all, we're going to build just a small system for like one person, one user with a smart AC, right? Then we're going to build it for professional users with smart AC. Then we're going to build the IR and all different kind of stuff, right? Yeah, let's make it a $1 billion business.
Includes a Serial Wombat chip running Serial Wombat firmware that can do the encoding and decoding of NEC protocol and make those available through an I2C connection. It's really convenient. It offloads a lot of.
Actually, ChatGPT explains this far much better. To frame what you're looking at, the real is roughly press a button, key matrix scans, remote microcontroller protocol encoder, 38 KZH PM generators, then IR LED drive transmitter, IR LED emits burst. Air, it passes through airs. So this is like a process you have when you press a button, right? Is there any way to directly send the phone? But I think, why am I even focusing on the IR part? This is something that I'm going to scale later, but then again, I need to know everything of the system. Photodite, transmitter amplifier, autonomic gain control, AGC, bandpass filter, demodulator, clean digital pulse, AV controller, patrol, execute, lookup table, protocol decoder. This takes out, like, yeah, the part most videos completely skip is that TV remotes and AC remotes are architecturally usually send only a small command. The same access command example, Samsung TV address it now volume up. The TV already knows its current state, so it increments the volume. Most TV remotes use protocols like itna now. AC remotes are much crazier. When you press itna, the remote often sends an entire state to it. Or air conditioner in a packet. Cool mode itna, fan itna, swing itna, turn off. The AC unit frequently doesn't maintain all state itself. The remote does. That's why replacing an AC remote is much harder than replacing a TV remote. Reverse engineering AC remotes often means decoding very long frames containing dozens or even hundreds of bits. For smart AC projects, this distinction is critical. You are not just sending temperature down, you are often replaying state packet. Understanding this architecture will save you from building up abstraction from this
provides a universal interface that you can talk to over C# or MicroPython or Arduino. It has congruent interfaces for all of those sort of things. So this board is pretty convenient. Has onboard I² C pull-up resistors if you want to. It has an extra.
Every growing industry has some sort of problems. Yeah. This is another insight that we can get from the AC industry, right? If something is used by many people, that means there's some problem that many people faces. Yeah, so you need to focus on things used by many people. Yeah, that's to make billions, if not like millions. Yeah.
Solder jumper that.
TV, AC, fans are something, but then again, what problems do we have in fan? Like we hate to actually change it. So we can have autonomous, but then again, if you're a company that works, but right. Everyone uses chargers, everyone uses water bottles, right? Everyone uses cameras, everyone uses phones, right? Everyone needs tables. I mean, these are the businesses that do well and continuously goes on to do well. But then again, competition is just insane, right? That's the problem. But besides that, like yeah, you solve an expensive problem, then yeah, the competition is not that insane.
Put if you're 3.3 volts or 5 volts so that you get the max out of the IR transmit LED. And there is also an IR 38 kilohertz demodulator available on this chip. There are solder jumper connections that allow you to designate it as any I² C address from 0x60 to 0x68. So again, these are available through a Kickstarter through March, the beginning of March of 2026, and will be available on Amazon sometime in the summer of 2026. When we talk about infrared remote control, we're really talking about 4 separate levels. The first level is the absence or presence of light, and that is invisible light, infrared, at typically about 950 nanometers. If you're picking out an LED, you want a sufficiently powerful LED that's right about 950 nanometers. The second is absence or presence of a signal. We call this modulation or carrier wave. And this is how an IR remote works in a room that's already flooded with IR signals from the sun, from heat sources, whatever. This is how we say, okay, there is an absence or the presence of a signal. Third is the IR remote protocol. And in this case, we're going to be talking about NEC. Other manufacturers like Sony and others have their own protocols, which this is how we encode ones or zeros by the presence or absence of a carrier wave. And then finally, there is the interpretation of that remote protocol, which says, okay, all we're doing over the remote protocol is sending numbers back and forth. What do those numbers mean in terms of a button? You know, does number 10 represent volume up or down? Does it represent I'm setting a color on a WS2812 LED strip? Does it mean
I think one of the biggest problems to solve in this system of the business we are trying to create is that every company has their own protocol and their own bits and own information, so it becomes increasingly harder to even connect to like yeah, and I guess when it comes to like so you would need a general what do you call it, a general IR or something. So for example, when you are creating a remote, right, or a general hub or something, what you would need, it would need the protocol encoder for every different company, right? And then as soon as like for your phone will only like yeah, your phone will set signal. Like here's the thing that I don't get: how could you send signal from a phone to a remote, like without using like wirelessly? Is there a way? Maybe through Wi-Fi, like that is the most biggest part of the hub, right? I mean, if you can't even do that, then it's almost impossible, become impossible to implement the solution or the company to scale. Whew, fuck, saved myself. But I literally thought, there's no way to actually then scale it. Because if you can't send, like, let's say, for example, I have my phone, and, like, this is the hub. I send signal to the hub. Hub send a signal to my fucking AC, if you can see up there. Right. Like, hub. So I send the signal, if you guys can see, right? If I send like this is my phone, I send the signal to the like from the phone, I send the signal to this hub. The hub sends back to that AC or to any AC either within the house within a certain specific range. But the biggest problem was if there is no way for the phone, like phone needs an IR infrared or something bullshit like that for the hub to actually get the information, then I'm fucked or something, right? Yeah, and I think I would need a lot of capital to actually not a lot of capital. I need to hire a lot of freelancers who would design this for me. Like, yeah, I need to hire some freelancers. Like that's why like right, I changed my camera angles for you guys to show AC consistently now because I think that's a better way for us to kind of like go through this entire journey of building up service for ACs. My mom's calling, but yeah, let's just decline that. I'm in a meeting right now. Maybe she's calling for breakfast or something, mom. Like I'm really working right now, babe. So you're touching the exact reason why company Broadlink. Let's just search like switchboard and yeah. So there are some companies. So I think this one super bridge infinite possibilities. Okay, but don't tell me they're expensive. Modules, built-in wireless, SaaS management, centralized system control, energy consumption. Smart living made simple. Broadlink delivers real estate smart solution. Okay, but what are the products? What are the products? Could you tell me like the products? Yeah. Smart screen, smart security. Oh yeah, smart security. I do know about that. Smart control. Smart switch. Oh, so it's not pro. Then we can kind of like create our own company that can actually solve all those problems. But yeah, or maybe we can get in a partnership with their companies, like they produce something for us, so that we can actually pay them. So yeah, smart code and get away. All right, there's smart sensors. Damn, these company. Okay, so we do got the solution, right? Wi-Fi, Bluetooth, Smart Hub, IR, LED. Like yeah, so the architectural usually. So yeah, reason the protocol problem is difficult, but isn't the biggest obstacle. The database problem, not a physics. It's a database problem. The architecture looks like phone app. You have Wi-Fi, Bluetooth, Smart Hub, IR, LED, TV, AC. The phone almost never talks directly to TV or AC through IR because almost all modern forces removed their IR blasters years ago. Instead, phone sends command to hub or over Wi-Fi or Bluetooth. Hub receives the command. Hubs lookups the approved IR code, emits the IR. Hub invents stuff. But every company has a different protocol. Yeah, this is like yes, Samsung has this, LG has this, Deakin has this, Mitsubishi. You need a library course out there. So, but you don't necessarily need to understand every protocol. Many universals don't understand the semantics. They simply stores power button. Tape recorders. The biggest problem AC remotes. Volume up, channel down, power, maybe 20 commands. It's like, can you have something for the TV remotes? But then again, the TV remotes are not that really hard to solve. But AC remotes are really hard a problem to solve, and this is what people would pay for. Like, what is the problem with TV remote? You get up and down. Like, what the fuck do you do with it? Like, yeah, if your remote doesn't work, buy a new one. Works for years efficiently. You can get a phone app, download it for the TV. Like, if you have a good company TV or something. Like, what is the problem? The problem right now that this remote solves is autonomous temperature control. Like if you have one day autonomous TV control where like a remote like pretty much dictates what to watch for you, but it's now never be able to do so, right? Like you would watch the things you want to watch. You would never watch things like that a remote chooses for you or something. Right, here's like right now, I'd literally have to increase the temperature. And that is the thing. I don't want to increase the temperature by myself. I just don't wanna. I just want to sit here and rot. Then how do a company solve that problem? That is the biggest question. How can you from a remote? But connectivity matters the most. At the start, you're going to be sending feedback from the remote, and from that, like right now, I shouldn't be using remote. I should be using my phone, right, to change the temperature, right? We need to fix that problem here in my room by creating a hub by ourselves, man. By buying the components that I need. Oh my gosh, I'm becoming an engineer out of nowhere. And then I have to scale the solution by hiring people, by building products that looks aesthetic or something. Like, yeah, then I have to invest. But before that, I need to target people with smart ACs. Only then I can actually get into the people who don't have smart ACs and make a universal product that works on every single fucking AC. And then I can hire a team that constantly added this to the database. Here's the important thing: you don't necessarily need to understand every kernel. Many universal remotes don't understand the semantics, and then you have to like have a lot of protection or safety against your own employees. Oh my gosh! The more you think about it, the more you realize just how much, yeah, work there needs to be done. See, remotes can have not 5 fan speed, 5 mode swing, sleep, turbo, echo, thousands of state combination. It's not power temperature fans, I know. Instead, it's that makes universal AC control much harder. The phone hub communication. Wait a sec, mama. Yeah, she came up with the breakfast, but then again, like you guys get it, right? Don't you guys get it at this point? It's kind of right. It's kind of obvious, or if not obvious, it's kind of too obvious that like we would need a lot of things. I need a lot of thinking on this topic. I mean, I need a my whiteboard close to me right now for some fucking reason. Let me just that. It doesn't necessarily need it to appear on the screen, but I need it for myself, right now, because like there's so many thinking, right? And then there's so many doubts that kind of like are appearing at this point, which we have to solve. And I need to also get my breakfast right, because like yeah, because we are gonna definitely solve this $1 million problem that's gonna earn us a lot of money. And I'll go back and come back from peeing again. Fuck myself. The first thing we are gonna focus on the most. The first thing we're gonna focus on the most is like yeah. The first thing we're going to focus on the most is like taking care of the smart AC, right? So first of all, we did realize that smart AC, like what is the architecture? So first of all, you have a remote, you have system one, you have like a remote which sends, so you have system, so you have a phone, the phone sends signals to this hub, which kind of like, yeah. So this hub has like it detects information, right? Okay, I have another idea. In fact, a very good idea. Are you literally shitting me? I got no choice but to. Oh my gosh, are you literally shitting me? I can't append this here, but okay, I can do it like there. This is why you need redundant systems. Where it is. Yeah, I think I should just wait a sec, I'll be back. Yeah, so we can add another audio input capture. Yeah, okay. And then we can say, you can upload a mini 3. Okay. Mm-hmm. So this is what it sounds like. And I think this should be able to hear from afar, like from here. Yeah, it's getting a lot better done. Job done. Right. So yeah. So this is what, like a good mic we have. No, I should make sure that I'm not hearing my own voice and other people are hearing more of my voice. But I think this is capturing pretty efficiently well. Right, so we have added another source of voice input. So now even if I move through different spaces or different stuff like that, you'd still would be able to hear me. But then again, we need to come back to our main point, which was like you guys know, right? The system design that matters a lot more than we think. It'd be better if I could get here or something, and then I can just pass through the back of it. Which is actually kind of hard to do, but doesn't really matter. You do not need a perfect system, right? For these kind of stuff. But literally, the thing with this is that the sensor has a lot. Like I never thought that that kind of would ever be a problem, but yeah, they never thought of it. They didn't design a system. They never thought of it, someone would connect it to a laptop, and besides that, because of the size, they won't be able to do so because there's a different sized. Like yeah, that's why it should have a like thin rectangle type design, I suppose. Hmm. But that would not be beneficial for phones, right? That would be kind of slightly annoying, yeah. But they can still add more height rather than making it like, yeah, they can still do it. Won't be a problem. It would be more like a, yeah. Design should not be something that looks aesthetic. It should be something that solves all the problem, and then it should be aesthetic. Well, this is something we can learn, but yeah. So first of all, you have like a phone. Okay. I think I should draw this, but for some reason, I just feel like doing it on the whiteboard. Like you can't blame me. There's something that just should be. So you have a phone first. Phone sends signal to the hub. Hub sends signal to the IR. All right. IR sends signal to the AC. All right. But each AC has a different IR, but each IR, like they have a different protocol. So like, do the hub send it to the IR, and then IR sends it to the protocol, or those IR has a protocol? Oh no, hub doesn't send it to IR. Hub sends signal like from the hub. We can know like from phone we detect which AC. From phone we detect which AC. So there's a detection process that happens in the phone. Detection process. So either like each AC brand, right? So you have brands, right? Brands have similar protocols. So you can select the brand, that selection. You can select the brand, but what about the Wi-Fi? Like how do you connect an AC to the Wi-Fi? But here's the thing, like if your phone, like the first process doesn't gonna include the hub or IR. First process is like a detection process, right? And that detection process would be able to like, brand, and then it's gonna like directly connect with the AC because of like the Wi-Fi, right? So it would be able to connect directly using Wi-Fi. So if you talk about the subsystem, but the next on the top of that, sooner or later we have to go with the hub system. Like yeah, so like anyone in India or anyone in the globe would be able to use it with any AC, right? Like so you have Wi-Fi, right? Because not all ACs are smart AC. So you have Wi-Fi, you can use the Wi-Fi. But if in the future every ACs are getting more and more like used based on Wi-Fi, then we can actually pretty much delete this thing because it's like an old gen, right? So even if like the new market is appearing, we can always still benefit out of that new market, right? Because like what you're doing, like yeah, so smart AC choice in the long run would definitely kind of like help us a lot. That is kind of given. And I think there's one thing I didn't realize is that Yeah, this is how you do it, right? So yeah. Hmm. That's how this functions, I suppose. Whatever she made it good. Yeah. So we have phone to Wi-Fi, Wi-Fi to AC. So, but phone sends signal to Wi-Fi, but because of that, phone needs to detect the AC. Means it needs to detect a protocol. So we need protocol detection system. Protocol detection system. I don't know if the system design that we are doing, the ST, is gonna work out or not, but I think it needs a protocol detection, and then it checks the protocol, and then it gets feedback on the basis of protocol or something, right? So it's like, yeah, so this is like our basic system design that's gonna go on here, I suppose. I think, right? So this would be our basic system design, in which you what you pretty much do is like you get a okay, right, you get a protocol, and then you work your way through it, right? Okay. All right. All right. So this is like if I were to zoom in for you guys, even I can see it right now. If I just look at my yeah, so from phone you've got a protocol detection. Protocol detection goes to AC. All right, different stuff like that. So yeah. Right, we can definitely switch it back to normal, I suppose. Yeah. So this is like our design for now, right? And now let's validate the design because it's like the option one phone router hub AC IR. So like yeah. Actually the easy part. The hard part is to find the protocol. The hardest part is to actually find the protocol. The AC remotes can have this. It's not it nights. Instead it's it now. Wi-Fi phone router hub IR AC. Advantageous option one Wi-Fi. Works anywhere in the house. Remote access over the internet. Support Wi-Fi. Remote access over internet. Oh my gosh. It's like, yeah, the Wi-Fi option, the phone, the router, the hub, the IR, the AC. So now I can connect, like, yeah, so if as long as I plus, oh my gosh, this is so good. All right. Bluetooth phone, Bluetooth hub IR. Option 2, Bluetooth phone, hub IR. Advantage, no router needed, lower power distance, short range, harder to control remotely. Yeah, but let's go with the router. I think like, yeah, this should cost somewhere less than 1,000. I think people would be able to buy the services even if they, yeah. Disadvantage, short range, hard to control remotely. Option 3, master plus Wi-Fi. Matter plus Wi-Fi. What is Matter? Matter. What is Matter? Matter is often a smart home template standard. Like Matter in the smart homes? Well, I've never heard of that. Smartphones. So that is not the hard part. Matter and what is Matter? Okay. Switch control menu with Matter over thread. 2.2 rewrite smart switch with manual control. Okay. Don't get what that means. Okay. Mation Matter. Okay, people are buying it. Wi-Fi. People are buying it. Whatever it is, people are buying it. You can turn on and off a plug using a phone. Are you fucking kidding me? Oh yeah, I didn't knew about a couple months ago that we had that technology. But I didn't knew it was so successful that thousands upon thousands of people were buying it. Fuck. That's a good thing. That's a good thing. That makes my easier for the product because if people are open to these products, that makes it even easier to kind of like, yeah. Smart plug. So I guess it connects with your Wi-Fi. Smart plug that added successfully. Make your ordinary appliance stop. Plug it in to make your ordinary appliances smart. So they get on and off by using a touch button or something. So you can control a lot of stuff with the phone. Automate everything. Take control of your home with, okay, automate. So you can like have 10 plugs and like you can on and off. Right. Ah, man, this happens with my, oh my gosh, this happens with my fucking fan all the time. But that's again, that's only if something is connected to this plug, not to the button itself. So it's, once again, happy device at home, Wi-Fi control TV on set schedules. Oh, you can also control anywhere. Oh my gosh, this is actually good. That, oh my gosh, thank goodness these fucking stupid people are actually building something great like this. But then again, the problem is like still you can't control like fan plug or something with it. It just doesn't. I want to control that. But what is this? A simple way to your smart home. What it does. Click to your Google Assistant, Apple Siri, Mirror certified smart home books. Control all your appliances from anywhere. Automatically. Voice control, remote access, mood based scenes. I don't get it. I still don't get it. What is Mirror? What is Mirror? I still don't fucking get it. What is Mirror? I still don't get it. Mirror plus Wi-Fi in your smart home to use measures. Which companies such as Project a connected home over chip layer instead of requiring manufacturing units separately with each smart home. How it works? Mirror over standard international networking device can to communicate using transport using Wi-Fi, Ethernet. Others. You should set a Mirror controller such as a compatible smart speaker hub or mobile device managers commissioning and automation. Yeah, so you're just sending signals using this to make yeah, this is basically where the industry is going. Your biggest misconception, you said if you can't send signal from the phone to remote, scaling becomes important. Actually, that's the easiest engine problem in the entire system. Command from phone. The difficult question. Ah, man, the difficult. How do you acquire IR codes of thousands of devices? Map every brand and model. How do you deal with proprietary AC packets? How do you recover if someone uses the original remote and changes the AC state? Update the base. Those are the reasons that becomes a software data business rather than electronic business. If I were attacking this market from zero, I wouldn't stop educating. I would build phone, Wi-Fi, hub. Whenever the user pressed the button on their original remote, locally, phone can replay them. You don't need to know Dickens protocology. Samsung Pro, the consumer's own remote, become the teacher. So you make it learn. We have something like this too here. Smart IR blaster. Okay, we already got this. Astro Smart IR blaster. I think I need YouTube for more data.
improvements as compared to the previous generation.
For some reason, my voice is just too high.
तो हे गाइस वेलकम बैक टू माय चैनल। आज हम करने वाले हैं एक बेहतरीन स्मार्ट होम डिवाइस जो कि है ये आईआर ब्लास्टर और ये आता है होममेड की तरफ से।
What's the fuck is wrong with the introduction? Just get the job.
कंट्रोल कर रहा था और फिर मैंने एलेक्सा को बोला था कंट्रोल दे दिया था, बट आज मैं करूँगा स्मार्ट लाइफ ऐप के थ्रू। मैंने आपको लास्ट वीडियो में बताया था ना कि जो भी डिवाइसेज हैं आपके कर सकते हो। तो कुछ डिवाइस आपको सपोर्ट करते हैं, जैसे अभी लास्ट वीडियो आपने देखा था एजियोट का, और यस चेक करने के लिए जो मैं लाइफ में भी पर ये नीचे ये रबराइज थोड़ा सा मटेरियल डाल स्लिप ना हो, ठीक है। इसके साथ एक ये है की तरह काम जो जैसे आपका जो भी एसी है, ठीक है, मैं इसके थ्रू यूज करता हूँ। तो जब मैं इसको सेटअप कर लूंगा तो मुझे इसकी रिक्वायरमेंट नहीं होगी। सेम फॉर टीवी, सेम फॉर प्रोजेक्टर, एवरीथिंग, बस वो आईआर रिमोट होना चाहिए। सो सेटअप करने के लिए सबसे पहली चीज तो मुझे इसको इंस्टॉल करना पड़ेगा। तो पहले हम इंसर्ट करते हैं। मैंने इसको यहाँ पे इंसर्ट कर दिया है, ठीक है। और आप ये देख सकते हो इसमें सो बहुत एक छोटा सा ये यहाँ पे एक डॉट है, ठीक है, जहाँ पे ब्लू लाइट ऑन हो जाती है। ये देख रहे हो ब्लिंक हो रही है। मैं दोबारा बटन दबा के दिखाता हूँ। सो ये लाइट है। अब इसको मैं क्या करूँगा, लॉन्ग प्रेस, ताकि इसको मैं पहले रीसेट कर लूँ। ये मैंने ऐप ओपन कर ली है लाइफ, ये हम सर्च कर लेते हैं। सो हम इस वाली ऐप को ओपन करेंगे, स्मार्ट लाइफ को। और ये मेरे कुछ जो डिवाइसेस हैं जो मैंने अभी आपने लास्ट मेरे वीडियोस में देखे होंगे, ये सारे वो आ रहे हैं, फैन 1 फैन 2 जो भी मेरे मॉड्यूलर स्विचेस थे। सो ये टॉप पे जो प्लस आइकन दिख रहा है आपको, ये इस पर क्लिक करना है और ऐड डिवाइस पे क्लिक करना है। नाउ इट विल सर्च ऑटोमेटिकली। जैसे मैंने आपको बताया मैंने डिवाइस रीसेट नहीं किया है। अब मैं अपने डिवाइस को रीसेट कर रहा हूँ। जो मैंने आपको एक बटन दिखाया था उसको लॉन्ग प्रेस करेंगे। ये मैं लॉन्ग प्रेस कर रहा हूँ, ठीक है। और ये देख सकते हो आप, अब ये ब्लू लाइट ब्लिंक हो रही है। नाउ चलते हैं वापस से ऐप में, और आप ये देख सकते हो स्मार्ट आईआर, ये जो डिवाइस है मेरा यहाँ पे आने लगा है, और ये आ रहा है बीइंग एडिड। ये मैं आपको बता दूँ, ये वाईफाई जो हम कनेक्ट करते हैं 2.4 गीगाहर्ट्ज़ को सपोर्ट करता है, और ये ऑटोमेटिकली अब ऐड हो जाएगा। तो ये देख सकते हो आप, स्मार्ट आईआर एडिड सक्सेसफुली, डन। नाउ ये कह रहा है कि आपका जो डिवाइस है अभी हमें मिला नहीं है, अब आप ऐड कर लो। नाउ यहाँ पे मेरे को अब चूज़ करना है कि मेरा ये कौन सा डिवाइस है। तो मेरा ये एसी है, तो एयर चूज़ करूँगा मैं। अब आ रहा है क्विक मैच अपना। पहले तो यहाँ पे हम ब्रांड सर्च कर लेते हैं, वोल्टास, ठीक है। ये कह रहा है कि क्लिक टू कंट्रोल। अब मैं इसको जब मैं प्रेस करूँगा ऑन एंड ऑफ, तो ये मेरे एसी में एक आवाज़ आएगी क्लिक की, नहीं हो रहा है वर्क। और हाँ, एक चीज़ और, सो इसके साथ मुझे ये ऐसे पेयर कर रखा है ताकि ये रिमोट को ना डिटेक्ट करेगा। यहाँ पे मैंने रख दिया है। अब हम चलते हैं वापस से ऐप में। तो ये देखो ये नहीं कर रहा। तो यहाँ पे एक नीचे बटन आ रहा है अनदर वन। सो अब क्या करेगा, ये पूरा एक अनदर रिमोट पे स्विच हो जाएगा। सो यहाँ पे एक और रिमोट आ गया है, नहीं वर्क कर रहा, अनदर वन, नहीं वर्क कर रहा, अनदर वन। कभी कभार ये फर्स्ट टाइम में भी डिटेक्ट हो जाता है, बट अभी देख रहे हो मैंने 20 ट्राई कर लिए हैं और अभी तक मेरा रिमोट का बटन नहीं मिला है। तो गाइस एक पोपट हो गया है। तो मैं सोच रहा था पहले स्मार्ट लाइफ की जो ऐप थी हमारी, उससे ही कंट्रोल हो जाएगा, बट मुझे लगता है अब होममेड से ट्राई करते हैं, क्योंकि जो स्मार्ट लाइफ है उसमें मैंने कई बार ट्राई कर लिया, नहीं हो रहा है। तो अब एक बार इस पर ट्राई करते हैं। वापस से मैं करता हूँ रीसेट। रीसेट हो गया। तो आप देख सकते हो यहाँ पे आ गया है डिस्कवरिंग डिवाइस, नेक्स्ट। नाउ ये ऐड हो रहा है। तो प्रोसेस सेम है, बट ये होममेड है और वो स्मार्ट लाइफ थी। तो ये देख सकते हो आप, ऐड सक्सेसफुली, क्लिक ऑन डन। इट सेज नो आई आर डिवाइस फाउंड, मतलब इट मीन्स कि कोई भी आई आर रिमोट मैंने इसमें ऐड ऑन नहीं किया है। तो यहाँ पे अगेन आप देख सकते हो, क्लिक ऑन एयर, क्विक मैच, और यहाँ पे अगेन हम सर्च करेंगे वोल्टास, जो मेरा एसी है बेसिकली, क्लिक टू कंट्रोल। तो मैंने अपना जो एसी का जो रिमोट था आईआर ब्लास्टर के पास रख दिया है। तो ये काम नहीं कर रहा। अगेन हमें क्लिक ऑन अनदर वन पे क्लिक करना पड़ेगा, और ये देख सकते हो आप, एक बारी में ही काम कर गया। आवाज़ आ रही है आपको? सो यहाँ से मैं प्रेस कर रहा हूँ, आपको आवाज़ आ रही होगी अगर सुनाई दे रही है तो। ये जो स्क्रीन है, ठीक है, यहाँ पे बटन आप नीचे देख रहे हो, अनदर वन, मतलब मेरा सेकंड वाले ही रिमोट पे वर्क कर गया मेरा ये डिवाइस। तो इसलिए मतलब पहले मेरे को लग रहा था कि वहाँ पे भी डिटेक्ट हो रहा है स्मार्ट लाइफ के ऐप में, तो हम वहाँ से कंट्रोल करेंगे, बट वहाँ पे उसने डिटेक्ट ही नहीं किया। मैंने पूरा 28 to 40 टाइम्स बार ये बटन को प्रेस किया, बट किसी भी बटन पे मेरा रिमोट डिटेक्ट ही नहीं हो रहा था। और यहाँ पे देख रहे हो होममेड के ऐप में एक बार में हो गया। तो अब हम यहाँ पे क्या करेंगे, ये अगर बटन आवाज़ मेरा कर रहा है, इट मीन्स तो ये बोल रहा है जो ऑन बटन है मेरा एसी पे सिग्नल जा रहे हैं आईआर ब्लास्टर के थ्रू। तो मैं कहूँगा यस, विच इज कैन कंट्रोल। अब ये बोल रहा है कि आप अपना जो ये बटन पे क्लिक करो और ये देखो कि वहाँ पे 18 डिग्री सेल्सियस हो रहा है कि नहीं हो रहा है। अब मैं यहाँ से इसको करता हूँ, ये जो लिखा हुआ आ रहा ना 18, मैं इसको कर देता हूँ 18। आवाज़ आई, और आप ये चेक कर सकते हो यहाँ पे मेरा 18 हो गया। सो हम इसको भी बोलेंगे कि यस, ये भी काम कर रहा है, आवाज़ आ रही होगी आपको। तो यहाँ पे हम क्लिक करते हैं कैन कंट्रोल। अब ये बोल रहा है कि इसको बटन को क्लिक करो और क्या आपका एसी ऑफ हो रहा है। तो चलो मैं इसको क्लिक करता हूँ और देखते हैं हमारा एसी ऑफ हो रहा है कि नहीं हो रहा है। और देख सकते हो आप, एसी हो गया ऑफ, कोई हवा नहीं आ रही, ठीक है। आवाज़ आपको आ ही रही होगी। देख रहे हो यहाँ पे कोई डिस्प्ले नहीं आ रहा है। एसी में ऑलरेडी जो कूलिंग वाली गैस होती है, इसलिए उसको टाइम लग रहा है बंद होने में। इसको कि भाई यस इट इज़ कंट्रोलिंग, कैन कंट्रोल। और यहाँ पे अब बोल रहा है ये स्विच ऑन, और ये देख सकते हो मैच कंप्लीट, तो मैं इसको बोलूँगा यस, कंट्रोल कर रहा है। और ये देखो यहाँ पे ऐड ऑन हो चुका है, तो इसको करते हैं क्लिक, और आप देख सकते हो यहाँ पे आ रहा है 24/7 टेम्परेचर, कोल्ड, स्पीड और ऑन एंड ऑफ। तो पहले करते हैं स्विच। सो देखो मैंने यहाँ पे अभी रिमोट रखा हुआ है, ठीक है, और मैं आपको ऐप से कंट्रोल करके दिखाता हूँ। सो ये देखो ऑन हो गया है, इसको कर देते हैं ऑफ, ठीक है। यहाँ से इसका टेम्परेचर मैं सिलेक्ट कर लेता हूँ, तो ये लाइट मैंने बंद कर दी है। यहाँ से मैं क्या करता हूँ, इसको एक माइनस करता हूँ, ठीक है। तो यहाँ पे मेरा 20 है, यहाँ पे भी 20। ये मेरा जैसे ये जो बटन है ये कोल्ड और हॉट के लिए है, और यहाँ से मैं ऑटो की जगह इसको फैन पे भी कर सकता हूँ। तो यहाँ से मैंने कर दिया ऑफ, और ये तो ये इसके फीचर्स हैं। बट ये जो मेरा एसी है ये
I
ऑटो को
see,
भी
I see. So they're like, you have to like manually try to control, and from the things I can actually kind of like understand or see from here again and again. It's like what I am kind of realizing over and over again is like that okay, that um that what was it again? Like yeah, so what we have like here is the biggest problem that we kind of like have. Okay, and I can actually have my normal camera catch. Oh yeah, this mic is catching, right? No, this mic is kind of muted. Yeah, let me catch that through this, and let me just mute this mic. Right. All right. Hello. Yeah. So my correct mic is catching up. So as I was saying, once again, I'll tell you what I was saying is like that what I did realize is like it's kind of like a manual. It just doesn't directly detect. So I think we can get a photo of the AC. So like a photo detector, so something that can actually easily detect the model number, the brand number, the expert. Like now, here's it's 27. Now I wanted to get 26. But once it gets 26, it gets colder, and then I need to switch 27. I just need exactly my app to do, right? To maintain the temperature. And then, like, yeah, we would keep on increasing complexity. Right now, it's just maintaining a temperature of a room with one AC, and like, yeah, but then it will be able to control it. Yeah. Yeah. Say hello.
Smart IR Blaster from Wipro. A smart remote that connects all your IR remote PCs.
Google, turn off the TV. Da-da-da.
Okay, hi guys. So this is the IR Blaster, aka infrared, aka your remote control. So this thing actually takes like a bunch of remotes, like all your remotes that you need. Maybe you're using a what you call this, an air conditioner, you've got a fan or your TV or soundbar. You can actually program all your remotes to this one thing, to an IR Blaster. And this one thing will communicate with your Google speaker. Like you can actually make commands with your Google speaker and your phone and everything. So today I'm gonna be actually what am I doing today? So today I'm gonna be showing you how to actually set up this IR Blaster on your.
This tiny black box costs $7 with shipping included, and you can use it to control and automate dumb devices like older TVs, aircon units, speakers, ceiling fans, and more. So in this video,
Yeah, we already have that. Like, I'm able to get it. Like, how, okay, all of this works on IR blasters, right?
Hey, what's up, Alex?
Yeah, so you have a projector, lender rack, television, ceiling fan, AC. I really don't like the thumbnail these guys are making. Let's check IR blasters. Like, yeah, so I built phone, Wi-Fi hub. Taking this market from zero, I wouldn't stop by decoding every protocol I would build. Wi-Fi hub with IR receiver. Whenever the user presses the button on the original remote hub learns code, stores timing locally, phone can replay them. Yeah, but a lot of these what do you call like hubs, IR hubs or blasters, like they can control multiple or simultaneous devices. I think, man, the problem they solved was expensive, man. But like what I want to solve and what they want to solve is like what I would need is their industry and their work to actually make my problem solve, because I want to create an autonomous room temperature control. That's the main problem we are targeting. When you go, whenever, wherever you go, like with the ceiling ACs, like, as long as you don't have a really really expensive, like, company, right, which has like this entire sensors in every area in every room or something, which is like entire. But like what I'm trying to do is like I'm trying to build a cheap solution for, like, because these companies have like a built-in like like you don't control the AC. It controls by itself on the basis of sensors, how many people are there, how much, like, but what I want to build is like an autonomous room control, temperature control, which saves electricity and controls the temperature in a room, in an office, in a hub, in a gym, in a sports, in an auditorium. All you need to do is connect one hub, if not hub, one application with all of the smart ACs you have, and it will automatically control all that by itself. All you need to do is just give it inputs on how many people are there, and like, and not even that. If we can also add some small camera that detects what's happening in the surrounding and can actually extract meaningful data out of it in the future, but not right now. Right now, I'm just gonna start with something basic, right? That's why I needed, like, when I thought, like, I don't know how this IR blaster works. Once again, like, they blast so much, like, yeah, how are they connecting, like, because at the end of the day what I did realize is like it's all IR receiver and IR transmitter. Like, they like IR receivers like at the AC or at the device, and IR transmitter, all you need to know is the protocol, like what kind of bit codes, what kind of bits should I send to actually achieve an output. That's all. The problem is the protocol. The IR receiver and the IR transmitter could be anything. Like, the receiver could be of any technology, of any component, but the main thing is like the protocol that they have, and each company has a different protocol. And then you have another thing, is like, how do we, like, you use a random, like, a random remote, right? So it sends a protocol to the DACin, but what happens here is that our receivers get that protocol into its own system, right? So you have a higher blaster, right? So you have an AC, you have a remote, and you have an IR blaster, which also receives the protocol you have sent to the AC, right? And yeah, and to the TV and to the SaaS. So it creates, it learns that, and now it can send that too. So it's like able to mimic, right? Which is like a surprising way to actually get around with the problem. So even if you do not have a protocol, you can still get the system going. So it's like, if I were to explain to my, like, yeah, to myself, it's something like, yeah. But yeah, the main problem is not like, yeah, this is one step of the problem. It's like, how do you get all different simultaneous AC from different brands, from different like, companies connected together, right? But at the end of the day, the biggest problem that we have, guys, is like, how do you actually maintain room temperature to an optimal degree for a certain specific person? That is another system we have to create. The system number one is just like not a system. I think, like, domain. This is like a first domain, because I've already named a lot of systems on the base 7 word system. Yeah, I'll leave that aside. But like, yeah, this is like the first domain we have to work on, is actually getting the software connected to multiple ACs and all that, and then another system plugging into that software that autonomously controls the AC. Oh my gosh! So this is like the two big things that I needs to add up or something, I suppose, if I'm all right. Right. Yeah. Man, you're almost late, but I still think you're misidentified where the hard part is. Device abstraction layer problem. How do I talk to town? They can produce something for each AC. Set mode cool, set fan auto. The abstraction layer translate these generic commands into basic specific IR packets. Universal IR actually do the state sync. This is where people underestimate the problem. Yes, system AC. This is it's nasty, many. Assume nobody touches the original remote. Cheap, terrible. Your hub has IR receiver. Much better. This is the cleanest. Autonomous climate engine. Above is plumbing. Nobody buys plumbing. People buy lower electricity bill, better comfort, less human intervention. Your engine might look like room temperature, humidity, outside temperature. Exactly. This is the business. We need to get the plumbing done. We need to get the plumbing done for the system to even work. Right. And I do need a IR blaster that not just actually receives the signals, but actually, oh my gosh, sends the signal and learns from the signal. Right. Only then we could have like a, yeah. Actual AC device layer. This is where the differentiation lives. Yeah, that is like right now. Fuck, I need to switch it back up. Add sensors, temperature, humidity, motion. Yeah, but I think the IR layer is like the that is like you know, the IR protocols. In fact, that is like the layer where the data actually travels or transports itself, right? Because think about it, like think about everything that I've just told you, right? Like because what I am realizing is like it may seem simple on the surface. Okay. Right. Whew. Actually, nothing. Yeah. Yeah, I did transcript. Cancel the transcript because I need to share. Yeah. I need fucking multiple monitors, man. I should beg my dad for it. Because then you have like a you have so much right here. Like if I'm being honest, like there's just so much. Like there's just so much. So first of all, you have the IR layer. So we have like multiple parts. First of all, we need to solve IR layer. Like IR, like the sensor layer, right? And then in like IR layer, you're sending. So this is for the people, the cheap market, those who do not have smart ACs and harder to reach. This is like a moat. Now you'll say why it is the moat, because I'll tell you, majority of the people who have like they have cheaper ACs, they have wind AC. Like this is moat. Moat means like yeah, the thickness. Like if you were to go about like here in our analysis, ladies and gentlemen, if you were to say where is it? Did we actually remove it? Yeah, we did actually remove it. Yeah, if you this is like if you take the mo if you like I think out of all these people that are using only about 1 million would have like yeah, so even that market is kind of important, but then again we need to reach the every market for it to have like a runaway feedback enforcement loop which like everyone knows about it, right? So once you scale the company globally, I mean like yes, it's like you have the entire oh yeah, and what does the ChatGPT even call it, like the systems that actually maintain. So because that is like the main thing. You try to maintain a room temperature by using the Google's API, by using all the different technology you had at your exposure. I don't know why everything is so dark for some reason. Let me just open that up. Yeah, some lightning finally. Yeah. So I like yeah. Oh my gosh, the light flow in my eyes. So yeah, so this is like the main thing. No matter how much you try to deny it, it's like uh yeah, we need to target even the normal residents, right? We need to create a solution for them and cheap solution. And the thing is, okay, only 3 million. This is the thing. Like every part of this, like yeah, these are the biggest markets. I wouldn't say like yeah, but yeah, why would they would need AC? Like these people don't need AC from Russia. I mean, but yeah, they don't have the heat temperature. I think Africans would need a lot more, right? Yeah, Australian would lead a lot less. Yeah, India, China, and Japan are the most developed in like in the central part of like Equator, where they learn lots of heat, so they would actually invest a lot of capital into solving that kind of problem. These countries are just not that yeah, bigger of a market. But then again, yeah. So we have hundreds of thousands of companies, and I think if you can learn, that's actually really better. And if you can create an explanation, and first of all, we are targeting China, United States, Japan, South Korea, and India. We are targeting these countries and Brazil, and Mexico and South Africa. We are targeting all these countries, but I think the priority is kind of obvious. Like we need to China, like yeah, these three, like these five are the priorities for Mexico, Indonesia, South Africa. Fuck you guys. especially this big bad boy here is the priority into like autonomous controlling. So yeah, can you actually create a system that companies can actually scale without ever needing to install the thing that they use? Like, so all they need to do is like they need to just install like what do you call it, like a basic system. Like, is it even feasible to create an application that can pretty much do all the math for them? All right, like it's all the math at the end of the day. So like an application that can do the math and can learn better and recursively improve itself even despite the stupidity or something. Okay, the benefit. And then you have to like make sure it's secure, then you have to make sure the market doesn't copy it easily, then you have to, yeah, I get it, guys, I get it. Don't I get it. It is a multi-million dollar problem. I just get it. I just get it. We would yeah. This problem, today is Monday, most probably. This problem is not easy to solve. I do not like lighting of my room a bit. I do not like the lighting right now a bit at all. Yeah, this is what I love. Right, so once again, if you come back to the point that I was making, is that, yeah, look, yeah, we need to target China, United States, Japan. We need to target these bad boys because they have like, yeah, we need to target these bad boys. South Korea, please don't, because China has literally 3 times the South Korea. So yeah, and South Korea is literally 2 times the India. So I think these and just like, yeah, just target China, man. Like if China is the biggest industry we've got here, I think we need to take care of a lot of like. I think we need to have our first self customer service in China too. Like we need to target China. We just need to target China. Like like these countries, just these countries, we just need to target them. As for the rest, fuck them. Because like South Africa just has like it like, yeah, bro, South Africa, you're just at 3, man. Like, are you fucking shitting me or something, buddy? Like 3 is and 569. That's just like these are just chimps. Like, yeah, these three are just like, yeah, these 3 and 4 are not worth the time. I think these things are worth, especially the top 3 are worth the time. A lot of time. Man, China is rocking when it comes to air conditioners, right? We need to actually know, like, yeah, and I do think like, yeah, once we solve the problem, we need to solve this problem for Chinese people. Damn, Chinese people use a lot of fucking like yeah, air conditioners. I suppose and then that means like, yeah, China is the biggest market of that. That means the, yeah. Fuck you, thanks you for making me understand.
और इसकी जो फैन की स्पीड है वो भी कंट्रोल कर सकते हो वाया एलेक्सा और मेरा एसी सिर्फ कोल्ड ही है तो यहाँ पे कोल्ड ही आ रहा है ये आप ऐसे करके सेटअप कर सकते हो इजीली सो अब आपका जो ये रिमोट है इसको आप कहीं पे भी रख सकते हो तो ये ज़रूरी नहीं है कि अब इसके पास रखना है ये सिर्फ सेटअप के टाइम मुझे इसके पास रखना था अब मैं इसको कहीं पे भी रख सकता हूँ अभी चलते हैं वापस से ऐप में एलेक्सा के थ्रू इसको कंट्रोल करते हैं ठीक है ये मेरा एलेक्सा का डिवाइस है इको तो करते हैं इसके संग कनेक्ट तो ये देखो ये मैंने एलेक्सा की ऐप ओपन कर ली है तो अब हम करने जा रहे हैं स्मार्ट कंट्रोल वो भी एलेक्सा के थ्रू मतलब एलेक्सा के थ्रू आप कैसे इंटीग्रेट कर सकते हो तो सिंपल ये मैंने एलेक्सा की ऐप ओपन कर ली है तो यहाँ पे आप प्लस आइकन देख रहे हो यहाँ पे क्लिक करना है डिवाइस और यहाँ पे हमें सर्च करना है होममेड तो होममेड ये बहुत सारे आ रहे हैं बट क्या करो आप यहाँ पे स्किल स्टोर पे क्लिक करो सो यहाँ पे पहली ऐप आ रही है होममेड स्मार्ट यही वाली ऐप हमारी होममेड स्मार्ट यहाँ पे ओपन हो रखी है तो हम इसको क्लिक कर लेंगे तो नाउ ये ऐप हमारी ओपन हो गई नाउ ये कह रहा है एनेबल टू यूज़ इट मीन्स हमारा जो इंटीग्रेशन है होममेड ऐप का और एलेक्सा का यहाँ से हम इसको अनेबल कर रहे हैं ठीक है मैंने क्लिक कर दिया है ये होममेड की ऐप पे लेके आया और पूछ रहा है कि भैया इसको एग्री कर दो तो हमने इसको लिंक कर दिया है बेसिकली तो यहाँ पे आप देख सकते हो होममेड स्मार्ट हैज़ बीन सक्सेसफुली लिंक्ड क्लिक ऑन नेक्स्ट एलेक्सा इज लुकिंग फॉर डिवाइस टू कनेक्ट तो अभी होममेड के जितने भी ऐप में जो भी डिवाइस हमने कनेक्ट करे वो यहाँ पे आप लेके आ जाएगा तो आप देख सकते हो यहाँ पे आ रहा है वन होममेड स्मार्ट एयर कंडीशनर फाउंड एंड कनेक्टेड क्लिक ऑन नेक्स्ट नाउ अब ये बोल रहा है कि आपका जो डिवाइस है ये आपने कहाँ पे रखा हुआ है तो मैं कह देता हूँ उसको भैया लिविंग रूम में रखा है एड टू ग्रुप एडिट कंटिन्यू डन नाउ अब हम क्या करेंगे इस एयर को हम कंट्रोल करके देखते हैं यहाँ से मैं देखो इसका नाम चेंज कर सकता हूँ एसी भी कर सकता हूँ तो ये देखो यहाँ से मैं अब इसको ऑन एंड ऑफ करता हूँ वहाँ पे मेरा एसी ऑन हो गया है दोबारा करते हैं ठीक है तो ये देखो ये रिमोट है इसको मैं कर देता हूँ यहाँ पे साइड में ठीक है मैंने सो रख दिया है और यहाँ पे आप देख सकते हो यहाँ पे दिख रहा है मेरा एयर इज सक्सेसफुली एडेड इन एलेक्सा ऐप तो यहाँ से पहले कंट्रोल करके दिखाता हूँ एलेक्सा टर्न ऑन एयर ये देख सकते हो आप यहाँ पे हमारा एसी हो गया है ऑन और दोबारा मैं बोलता हूँ एलेक्सा टर्न ऑफ एयर ठीक है यहाँ पे ये ऑफ हो गया तो ये जो एलेक्सा की ऐप है मोबाइल में मैं उससे कंट्रोल कर रहा हूँ और मैं इसको बंद करके वहाँ पे भी कमांड दे सकता हूँ तो जैसे एलेक्सा टर्न ऑन एयर ठीक है, दोबारा बोलते हैं, एलेक्सा टर्न ऑफ एयर। सो ये आप देख सकते हो एलेक्सा के थ्रू भी इंटीग्रेट कर लिया है। और लिटरली बताऊं, ये मैं डिवाइस पिछले 15-20 दिन से मैं यूज़ कर रहा था। लास्ट कुछ दिनों से मैंने इसको डिलीट कर दिया था बिकॉज मेरे कुछ वहाँ पे भी सेटअप हो रहा था। तो जैसे आप देख सकते हो यहाँ पे नीचे मैंने लाइट इंस्टॉल करी हुई है और थोड़ा सा एस्थेटिकली अब अच्छा लग रहा है कंपैरेटिवली। जब हम देखते हैं तो बहुत ही बढ़िया लगता है। ये मैंने एक एलईडी स्ट्रिप लाइट लगाई है, इस वीडियो का पार्ट नहीं है बट मैं आपको बता रहा हूँ। जैसे मैं आपको दिखाता हूँ, एलेक्सा टर्न ऑफ लिविंग रूम। तो ये देखो, तो ये जो सेटअप है जब आपका टीवी ऑन होता है, एलेक्सा टर्न ऑन टीवी। तो ये देखो, जब आप टीवी और ये जो लाइट के संग जो इफेक्ट आता है ना रात में होम थिएटर का, बहुत ही नेक्स्ट लेवल है। अभी एक और प्रोडक्ट आने वाला है, वो मैं दिखाऊंगा। इस टीवी के संग हमने ऑर्डर किया है जिसका मैं बहुत टाइम से वेट कर रहा हूँ। फिलहाल उस बारे में हम बाद में किसी नेक्स्ट वीडियो में बात करेंगे। बहुत बहुत बेसब्री से उसका इंतजार हो रहा है। तो फिलहाल करते हैं लाइट ऑन। एलेक्सा टर्न ऑन लिविंग रूम लाइट्स। सो अगर मैं बताऊं कि ये मैं 1-1.5 महीने से यूज़ कर रहा हूँ, ठीक है, पूरी गर्मी मैंने इसी को यूज़ किया है। मतलब इसका एक ड्रॉबैक है बस, कभी कभार ये सुनता नहीं है, ठीक है, तो देखना पड़ता है यार क्या हो गया। तो जैसे 10 में से अगर मैं बोलूँ तो एक बार ये मिसिंग कर देता है, मतलब सुनता नहीं है तो दोबारा से देखना पड़ता है। बट आपकी जो ऐप है एलेक्सा या होममेड की, उसके थ्रू आप करोगे तो वो तुरंत सपोर्ट कर देता है। तो एक बार ही मैं बोलूँगा, कभी कभार ऐसा होता है, ऐसा नहीं हर बार आपको प्रॉब्लम देगा। हो सकता है कभी कभार ये डिवाइस जो है मुझे लगता है कि स्लीप मोड में चले जाता है, क्या होता है। तो आप इसको एलेक्सा के साथ इंटीग्रेशन करके सीमलेसली फ्लोलेसली यूज़ कर सकते हो। बेसिकली क्या है इसकी बस एक ही लिमिटेशन ये है कि जिस रूम में आपका जो भी डिवाइस है जो कि आईआर रिमोट है, उसी रूम में ये आपको सपोर्ट करेगा और उसी रूम में आपको ये कंट्रोल कर सकते हो। ऐसा नहीं है कि आपने सारे डिवाइसेस से तो कंट्रोल कर लिए एक बार, हर रूम में जा जाके आपने डिवाइस दिखा दी भाई ये मेरा आईआर है और इसको कनेक्ट कर ले, ऐसा नहीं हो सकता। तो इसके लिए आपको हर रूम में अलग अलग ये आईआर ब्लास्टर रखने पड़ेंगे। अगर लेट से एक ड्राइंग रूम में आपके 2 एसी हैं तो उन दोनों एसी को आप इसके थ्रू कनेक्ट कर सकते। आई थिंक ये जो मुझे पड़ा है ये 900 रुपीज़ का आता है आईआर।
Yeah, so I pretty much got like what industry has and what and like yeah. Damn. Hmm. Yeah. Never in my life I would have ever thought that I would think this much about AC just about like yeah, until a week ago. Your engine might look like room temperature, humidity, time of the day, historical cooling date, electrical prices, comfort preferences. Let me just turn off the light a little bit. Let me just turn that off completely. Yeah, even if my face isn't that beautiful, sorry, you have to just bear with it. I'm not in the mood to turn on the lights right now. Time of the day, and then you have prediction comfort to an optimal AC device LED. This is your actually differentiation left. Yeah, it's heat problem. Basically simplified HVC engineering. Yeah, I think Havoc engineering. This is the main thing, right? This is the mode. This is what we're trying to do in simplified. Like discipline focused designing and optimizing heating, ventilation, air conditioning system for building, ensuring comfort, air quality, energy efficiency. Right, there's an entire industry, like entire industry behind this, right? So like yeah, so we can actually get into YouTube and we can know how do these fucking bad boys functions, right? Because unlike Havoc engineering, what we are trying to do is like yeah, they're trying to do that for everything, every part of the building, but we are trying to pulling on data through Google, right? So Google Maps, right? No, yeah, so we are using that API to know a daily life.
Is to diagnose a broken heating or air conditioning system, provide options to a homeowner for repair, and once the homeowner makes a decision, be able to provide those repairs and that service to get that heating or air conditioning system up and running again. You know, I chose this job because I knew I didn't want to go to college. I was still in high school, and if I wasn't going to go to college, I had to find some type of career to be able to support my life. And I decided to get into the trades. Heating and air conditioning sounded interesting to me. So we're on our way to our first call.
It's time to put these in my bag. Bring out the probes.
That unit is pretty old.
They already had one person came out and he's like, he was giving me the price to replace it, and I'm like,
Yeah.
we're gonna look to repair it, dude. He's like,
Yeah.
you're not gonna get that repaired.
I'll take a look right now. I haven't opened it yet, but from the outside it looks really old.
Yeah,
it's
the
old.
original one from the house.
That's crazy, yeah.
70s.
Wow.
Yeah.
Yeah. Okay.
Here we have our basic refrigeration cycle PowerPoint for new students to understand and we have this side in red and that side on blue because this is the high pressure, high temperature side, and the other side is a low pressure, low temperature side. And you have two components in any system that separate the high and low pressure sides, and that's the compressor and the metering device. So the compressor's job is to increase the pressure of the refrigerant in order to increase the temperature. The metering device's job is to
Have you ever wondered how that magical machine on your wall keeps your room cool on a scorching summer day? Today, we take you inside one of the most advanced air conditioner factories in the world, the Daikin production plant in Hanoi, Vietnam. Let's uncover how Daikin, Japan's #1 AC brand, builds its powerful air conditioners from scratch. Let's begin. The birth of an AC. It all starts with plastic molding. The journey of every split air conditioner begins with precision plastic molding. Using high-pressure injection machines, molten plastic is poured into detailed molds to form the outer casing, indoor grills, and fan blades. These parts aren't just for looks. They're engineered for durability, airflow efficiency, and noise reduction. The indoor unit's grill, frame, and fan components are made using precision molding machines. Every curve, vent, and blade is crafted with accuracy. Even the cross-flow fan, the long rotating cylinder that pushes air into your room, is molded here. Engineering the heat exchanger. Next, we dive into the heart of the air conditioner, the heat exchanger. Copper tubes are bent into U-shapes, called hairpins, and inserted into layers of aluminum fins. Then, the entire structure is bent again to maximize airflow. Pipes called U-tubes are inserted to connect the flow. All connections are soldered, a process that requires both heat and expertise. Ultrasonic magic and precision. Now comes the ultrasonic welding process. Instead of glue or screws, these fans are welded together using high-frequency sound vibrations. It's clean, fast, and super strong, but it doesn't stop there. Each fan is balance tested by spinning it at high speeds to ensure it runs smoothly, no wobbles allowed. A dimensional inspection also confirms the fans meet exact size standards. After that, gas is sealed inside the system to test its pressure strength. Engineers carefully...
Manufacturing is so fucking insane. What's wrong? What's wrong with manufacturing? What's wrong with... Okay, I just saw a factory producing an air conditioner, and I realized manufacturing is so fucking insane and complicated. So many machines doing certain specific jobs again and again. How do they, like, oh my gosh, how do they get all of that set it up? All the protocols, all the worker, how did the worker know? Like the team, it must have taken years to build those factories, man.
check for any leaks. Once confirmed, the gas is recovered for reuse. Then, a seal plate is installed to lock everything in. Assembly of the indoor unit. Now it's time for the indoor unit assembly. Sealing materials are attached, the crossflow fan and heat exchanger are mounted, and electrical components like circuit boards and sensors are installed. Another leakage test ensures safety, and the front grille is snapped into place. Before leaving the station, the AC unit undergoes a high voltage test to ensure it's electrically safe. Then, engineers perform an operating inspection, basically turning it on to make sure it cools perfectly. The outdoor powerhouse. Let's move to the outdoor unit. The massive housing is shaped through press and paint processes, followed by resin molding and the propeller fan molding. These large fans are crucial for heat dissipation. Assembly begins. A coupler is installed to connect indoor and outdoor units. Then comes putty for sealing, and soundproofing materials are added around the compressor to reduce noise. The propeller fan and side plates are installed.
It's giving me goosebumps. Ah, could you, it takes, could you just look at the civilizational power? Could you just marvel at its awe of what they've achieved here? A dumb labor may never understand this, but
just like before, the unit undergoes a withstand voltage test to ensure electrical safety. A final nameplate label is attached before packaging. Finally, both indoor and outdoor units are carefully packaged and prepared for shipment to homes across the globe. So the next time you feel that cool breeze from your Daikin AC, just remember the incredible engineering, testing, and precision that went into making it.
my gosh, oh my gosh. I just can't stop. Buddy, it's giving me goosebumps. I just can't stop. I mean, like, I just watched one video and that's like the more I think about it, in the past I've never thought about this, never paid much attention, but it's like the sheer audacity and complexity that a company like that has. Like the sheer, like the one who built it, like, oh my gosh, just think about the one who built it, all these systems, all these checking, all this iteration, thousands of iteration, thousands of complexities, prediction over what to do, what not to do, what will lead to profit, what will cut the profit, what will the margin, what is feasible, what is not feasible, decision over decision over decision, right decision again and again and again, making wrong decisions, getting mistakes that are expensive, iterating over those false decisions, but then once again making the right decisions. Oh my gosh, done repeatedly over the years to build a factory, man, to build a factory. And then that factory somehow becomes old because there's a new product, and there's then competition, and then there's, you know, advertisement, and then there's apps, and then there's like different, oh my gosh, just how are you doing that? Insanely insane. catastrophically expensive problems. Business owners solved catastrophically expensive problems that people are willing to pay for. Catastrophically complex problems that somehow otherwise would be impossible for normal people to solve by themselves. Oh my gosh. I'm having a 5-minute break. I'll be back, man, from water, and yeah. And there's another one thing that I kind of like myself realized is that, which is kind of pretty obvious at this point, it's like some problems are easy to solve. YouTube is not what? The instant streaming as such viewers will they would prefer buffering, or they'll get it buffered or something. Yeah, that's alright. Yeah, to be honest. Yeah, so here's the main thing that I would say. Okay, where's my AC? Yep, we got that bad boy on. So, yeah. Chemical producing refrigerators, chemical software companies making design tools, universities training engineers, supplying electricity, post and shipping networks, moving materials, bank finances, expansion, government making system companies that build the machines that build the AC. And then the true lips of the machine depends copper tubes was probably manufactured by another factory that itself uses machine built by other factories. Factories build machine that build machines. At some point you stop seeing any air conditions, start seeing civilization a vast recursive web of accumulated knowledge, and yes, stop people making expensive mistake. Tiny decision flow can get thousands of warranty claims of forecasting error. Can leave errors full of unsold units. The entire company has died from getting these decisions wrong, yet humanity keeps iterating. This is why manufacturing often gives engineers frozen intelligence. Every conveyor belt, every checklist, every robotic arm, every warning label is a piece has been compressed into matter. A factory. This philosophy made can billions of individual minds spread across time and space, coding well enough to turn rock, oil, sand, and electricity into a machine that cools you. Against all intent, the answer is yes, and that is genuinely straight. Damn, it's so beautiful. What we have achieved, man. I just can't stop thinking about it.
The thing I like most about my job is the problem-solving aspect. I really enjoy digging into an existing building and figuring out what's wrong, or why it's wrong, or what the history was, and how it got to where it is. It may be something that they've dealt with for a long time, no one else has been able to figure out. You come in and solve the problem, and they're eternally grateful. My name is Doug Lutz. I'm a mechanical HVAC engineer. I work for Sebesta Blomberg & Associates. HVAC, heating, ventilating, and air conditioning is what that acronym stands for. And essentially it's heating, so it's providing heating for commercial buildings or industrial buildings. Ventilation, bringing outside air into the building to make the occupants more comfortable. And then air conditioning, so providing cooling for the building to make sure that the space temperature is somewhere between 70 and 74 degrees for commercial buildings. Your whole goal is to try to figure out how it's going to work, what it's going to do before you even spend a dollar trying to build it. Usually start around 8:30, working with a vendor who sells a product that we might want to purchase or specify for our design, giving them a call, talking to them about what our options are, reviewing the construction, reviewing what they've installed, making sure it's
beautiful again.
HVAC, heating, ventilating, and air conditioning. It is. It may be something you're able to figure out. You come in grateful. My name is Doug Lutz. I'm for Sebesta Blomberg. Heating, ventilating, and air conditioning is what that acronym stands for. And essentially it's who sells a product that we might want to purchase or specify for our design, giving them a call, talking to them about what our options are, reviewing the construction, reviewing what they've installed, making sure it's consistent with what we design, meeting with an owner and understanding what their requirements are. You go out to the site, you have to physically test the HVAC systems, make sure that they're operating the way the design engineer intended. So either by car or by plane, depending on how far away the site is from your office, there can be anywhere between 5 to 50% travel. I went to South Dakota State University. I enrolled in mechanical engineering. Interestingly enough, the classes that were early on in my engineering career were the most difficult. Those were the ones I had to buckle down and study really hard for. As I got further in my engineering career, the classes actually got easier, which was a sign to me that I was probably in the right, in the right field, in the right industry. When I graduated, I decided that I would stay on a couple more years and get my master's degree. So as a mechanical engineer, probably the two most important things in this business are communication skills and problem solving skills. Problem solving is absolutely, it's actually one of the most enjoyable things about this industry to me, or about engineering in general. It's a challenge to come in every day and have a different kind of problem to solve. Being good at problem solving and having an aptitude for that is very beneficial for engineering and this industry as well. One of the most valued skills in this industry is the need to be able to communicate clearly with your coworkers, with the clients you work for, and the product vendors that you work with to complete a design. The tools we use every day are usually software-based. You're on a laptop, you're on a computer, you're running simulations of energy performance, or you're running load calculations to determine how much energy a building's going to take to keep it at 72 or 74 degrees. And you put in the parameters, the physical parameters of the building, the geometry, the windows, the roof. You make assumptions or get information on the people, the lighting, the equipment, how long the building's going to be used. The other tools we use are usually like handheld temperature and humidity devices, pressure gauges, pressure devices, where we go out to the field and measure pressure, temperature, and humidity. Being an HVAC engineer in Minnesota, you're exposed to so many different temperature and humidity extremes. It's different than being an engineer, for instance, in California, where it's usually 72 degrees all the time. You don't have nearly a temperature difference between inside and outside, whereas in Minnesota, you've got a design for a 100-degree day with 50% relative humidity versus minus 16 and zero humidity at all. A large percentage of the energy that's consumed in the United States goes to heating and cooling buildings. Fans, pumps, air handling units, cooling towers, chillers. All of this stuff takes energy, and it's all just for occupant comfort or safety of the occupants. And as a design engineer, as a mechanical engineer in that industry, you have a tremendous opportunity to be able to reduce that energy consumption. One common misconception is people who have an aptitude for this are good with numbers, they like numbers, and all they want to do is work with numbers. The reality is that, yeah, you do work with numbers every day, but just as important to that is your interpersonal and communication skills. Communication skills are extremely important in that you are always trying to communicate with owners, with vendors, with your coworkers, to try to help them understand what your idea is.
Yeah, so this is what they are pretty much doing. I think there's a big industry for HVAC, right? That's why there's so many courses online.
Channel.
Right.
Heating, used during winter to keep the environment warm. Common heating systems include furnaces, boilers, and
heat pumps. Yeah. Yeah, so we have HVAC, right? Document 2.
This is Craig Migliaccio.
But I think we won't be needing that. We would be needing the entirely different data and entirely different responses to those data, right? Because we won't be using different kind of systems. We would be just trying to what are the outside environments are. We wouldn't be using complex systems that actually try to gather that. Yeah. Yeah, man, that's kind of beautiful. Right. Yeah, like I would attack and phase the same single room, single smart AC manually. Can manually comfort better than a human? Motion door close goal. Can I estimate heat load? Room AC goal. Can I coordinate them? Right. Computer vision. Right. Camera estimates number of people, activity level distribution in the room. Where room is empty, goal predict that generation. Automatically predict heat generation automatically. Minimize energy cost of maintaining human comfort. Those are different objectives. Sometimes it's not comfortable, sometimes it's not. Because humidity is low and fans are moving. Sometimes it not feels awful because it's a. So how do these HVAC engineers, right, if that's how you pronounce it, what do you call it, like HVAC engineering? These engineers, how do they solve the problem? Because what we're trying to do is the phase one is kind of simple, right? You've got a single room and you're trying to maintain. So what I'm trying to do in my business is you try to pull up the data from Google or stuff like that. So you get a lot of your data online, right? I mean, like yeah, through Google services. So you can pretty much know the rough temperature of a city, of a locality, like an approx temperature, and like how is it going in that locality, and like and stuff like that. And you can pretty much use that, right, to know about like what, like to keep a pretty good guess about, okay, if this is a room and this is like the city they are living in, this is the normal temperature of the city, and like how much should we change the temperature for them to feel comfortable or something, right? So, and then we kind of like ask their body inputs, like their age, weight, height, and stuff, and then we calculate the BMI and like their ideal body temperature, right, by taking and then the size of the room. So we pretty much try to predict like what would be like the ideal room temperature for them, and by using that we kind of like generate like ideal room temperature or something. But what I want to know is like yeah, and the AC, like the remote controller maintains itself, and then we can add sensors too in our hub that we create in like the hardware that we create in the future. So like the hardware can actually receive like receive like IR signal, can give IR signal, learn from different IR signals, so if it doesn't have it in database, like and also it can actually check temperature, humidity, like stuff like that in the room, and then it would become a far, but it's a small hub, right? And like how long like a door opens or closes, no, that's not necessarily needed, right? As long as it does not need information about that, it can just like humidity, temperature, and like in the room, and that in itself allows you to create an ideal room temperature because you have already calculated the ideal body temperature for someone else's body, right? All right, so you do not need, because it's like it creates an own universe within a room, within a hall, right? So it's constantly detect those things within a hall or something, right? Or within a room. So it's like this is one of the best things you can, because like I think HVAC, I still don't know how to pronounce the full thing, but yeah, HVAC or whatever. Like HVAC, like these kind of engineering people from this industry is like I think they designed it for complex buildings, but not everyone have complex buildings, in apartment or something like that. You have a normal house, so you can buy a like a sensor like phase two, which is worth less than 1,000 rupees, and you can put it in a corner of your room, and then you'd have to never worry about the room temperature anymore, like whether you're sleeping, whether you're waking up, all the different kind of stuff, right? So it's personal optimization. But then again, if you have functions or parties, and when you have a hall, even in those kind of situations, you never have to worry about the room temperature, right? Because like yeah, because it doesn't need the room temperatures to know that 100 people ideal room temperature would be somewhere about 26 to 28, right? But if the more people are, then there's more heat. So in order to achieve that, you need to actually decrease the amount of like the AC power. So like you have to make sure it's running at 18 or 17 like degrees Celsius, so that it kind of like produce enough cold for the actual room temperature to hit 27 or 28 or 26 or something. So it's like yeah, it's a very simple thing and does a very simple job effectively, right? And it causes, and then it can also calculate the like the hardware or the software. Like I think this would be better than on software. It's like it can simply calculate like how much cost there is, like okay, what AC do you have? This is where the screenshot picture, like not screenshot, like a photo taking picture, so you can take a photo of your like AC, and it can probabilistically pull information regarding it online using APIs, like and once that is done, it can pretty much estimate like the cost you're paying and how much money of it has saved you by smartly maintaining a room temperature, right? Distribution, like yeah. So yeah, that's what I'm doing. But I want to know like what these engineers do though, right? Because like they are solving a way more complex problem that I'm solving actually. Now that I think about it, yeah. Adequate ventilation. Adequate. Adequate engineers have or adequate. 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 Adequate engineers. Adequate engineers solves problem much. But I think ChatGPT, I mean, IDE is like, ideal, sorry, IBE, like ideal IBT or something. But I think the IBT, the ideal body temperature, is kind of important. Like, give me reasons why it's not important at all. Because like a fab man, like yeah, you're wrong about the clothes parts too. I mean, like yeah, we can pretty much predict to what kind of clothes someone wears and how much they would change like the heating on their body, right? If we because since we are using weather API, we pretty much know their location. That means we can pretty much know what kind of clothes in that locality is common, so we can pretty much predict. So from idea of like IBT, like ideal body temperature, was that like yeah, I mean all my ideas are correct, like weather API idea and like yeah, and you're right about the fundamentals, but the reason why we calculated that, because it really takes not much time to calculate that, and with that we can know if someone would prefer beforehand without even the system even starts, because all they have to do is put their like, which takes literally 10 seconds to put their age, height, weight, and like yeah, stuff like that, and then from that we can calculate their ideal body temperature scientifically, which is an approximate to know the preferred ranges like periodically. And then you're right about the clothes, we can also predict that, so it's like point some like Celsius up or Celsius down, right, or something. So it's like we are not creating a complicated BMI model. What we're pretty much doing is getting some basic input in the size of the room. Because like what I'm trying to build is just through the app, because you can never know. You do not. The reason is I do not have like the first version that I'm building. I do not even have like a hub or a IR transmitter or a temperature sensor or humidity sensor. I only have weather API and a simple learning algorithm. And at best, I know the product like they are using, and I know the size of their room. This is the only initial condition. Those are the only thing: the humidity sensor, the temperature sensor, the IR transmitter, the ESP32 hub. Is like all of those things. Like, and I can create an entire hub by myself by adding all of those things. But that is only possible if they are willing to buy a hardware. But I'm not starting with hardware. I'm just only starting with a simple demand for smart ACs and rich people right now. See, for that, I think this kind of information becomes a lot more important. Yeah, ChatGPT, I realized. I mean, I still don't think that ideal body temperature is entirely useless, like you say. But I would agree that yeah, because I think a lot of time, because I've been, oh my gosh, yeah, people do give signals all the time. So for example, at night, like if I could have like user preference, indoor measurements, not specifically like historical behavior, and like the outside temperature or something, like a little bit idea about what's happening outside, then I can pretty much predict from their behavior is like what's the ideal temperature. Because my ideal temperature, what I realized, especially in summers in the morning, it's somewhere about 26 to 27, but at night it becomes 27 to 28. And I automatically, literally remember waking up at night and changing the temperature because it was getting too cold at 27. So I was changing it again on 28 or something. So this is my ideal temperature from somewhere between 26 to 28. And literally, that's majority of the time I use it. So I can pretty much predict that in summers in Rajasthan, I mean, I used 26 to maintain myself initially. Right. And but what I was doing with the ideal body temperature IBT is like, first of all, my ideal preference range, because body has to maintain 37 degrees warm. Right. So like yeah, 37 degrees Celsius, like internal body temperature. So for that, it requires an outside some sort of coolness or hotness, right? So it's like how like the how like the body requires like ideal body temperature is not the ideal body there's ideal body temperature, I mean like the outside ideal temperature required for the body to maintain that 37 degrees Celsius, and that kind of like changes across, like, yeah. So I would still push back, right? Because I think you're just kind of rejecting it for the sake of rejecting it, because no one is actually using it and it's not in your database or something. Because by that we can actually got a really good prior which pretty much tells us this person approx ideal body temperature is this, and now if they change, right, if they change, let's say per se, if they change the temperature, they increase it, right, and they kind of like decrease it, then we can update them all, and then the user preference, like starts to appear. Then we got historical data, we can actually from user preferences under certain context, okay, there's this ideal body temperature, then we have a API, like the API, like, so there's the weather outside in the area, there's humidity, so now that starts to build a context, there's this time of the day, right? And now what's happening is like you are able to, like calculate, so now you have historical context for user preferences, right? So now you can pretty much, like, as soon as there's some context available, you can pretty much set the temperature by yourself without any hard work or something like that, right? So yeah, so that's like, yeah, so if like a user gets too cold and they close it at certain, like, yeah, and yeah, so people love it when, like, something closes their AC because they think it's saving the money, and something opens. So it's like every 5 minutes when the room gets too cold, they set it to 18. When it gets too cold, they close it off and then they open it again. So if that is what user behavior is, or user preference, it kind of learns from that too. But the reason why I need IBT is like we cannot perfectly learn from like their behavior, because like with ideal body temperature we can know that this user needs somewhere about 22 to 24. This is our prediction, but the behavior of his is like 18. He sometimes run the AC on 18 and he shut it off, but that is just like bullshit, right? So we can know, like, yeah, that's why, like, yeah, so if we can have a power saving mode where it's like it runs on high, and yeah, something like that, like it runs on 18 degrees Celsius and then it closes off and then opens again, and like does that to realize, because it takes 5 minutes for the room to get cold, and that's when the owner starts to feel cold, so it like it closes off, just like the AC, turn it off like just at 4 minutes and 30 seconds or something. That's another thing. But yeah, but how would you ever gonna bootstrap a basic simple prediction, man? That's just impossible without the ideal body temperature. It's just fucking bullshit. ChatGPT, you're bullshitting. You're bullshitting. You're literally bullshitting. Because, like, how do you know what kind of temperature someone's like, right, from the preferred state of what they're doing? But then again, how do you know? Let's say, for example, let's say I enter a room and what kind of temperature do I like? How can you answer that question? For example, you have a complex building where the people that are coming in the room are constantly changing, right? You have HVAC engineering, right? How do they know that what kind of temperature is ideal for the body or for the most of the body? They still have to maintain some sort of temperature in a building, right? So they do make some ideal body approximations, right? Like, you are pretty much hallucinating at this point. Are you not? And you can. I mean, I've seen fat people needing more. I've literally have evidence for it. If you are a fat person, then the chances of you requiring a cold environment is a lot more than if you are a thin person. I've seen it in my own, in front of my eyes. What are you saying? Happening with my dad and my brother, they are fat. They want colder environments. So if they have a fat body, they generally requires cold environment. If you have a thin body, if you have low body fat percentage, you require a warmer environment. Like the prediction you were telling it's 5%. No, it gives you pretty much a good initial start as to where to start with. Literally. Like, okay, you're just dismissing it because HVAC engineers don't use it. I don't care. I mean, it is important data. Give a valid reason. You're just saying, oh, people requires, people are comfortable at different temperature at different times. No, that's because of clothing, that's because of environment, and this is what exactly my system calculates. This is what gives the like enrichedness to the context. It keeps track of the outside environment, keeps track of someone's ideal body temperature. That's where you get the context from. It keeps track of what approximately or like, statistically they wear in a home. You can even ask questions related to that. So under those contexts, it gets a lot of good information. Oh my gosh, that's such a wrong reasoning to justify a point that doesn't make sense. I think it's about to test our equations. Okay, let's start with me. My height is somewhere about 5'11 to 6, so let's just take 5'11. Right, my weight is 67. Right, and like my room is somewhere about these gas plus lumps. 430 centimeters, right? It's like, yeah, so 430 is like 430 centimeters. Let me just write it. Length is 430. No breadth. I think breadth would be longer, I suppose. Four. It's about a feet big. So here we have 14, right? We have person 8 feet. Eight, 5, 13, 14. Less. 8, 5, 13, 14, 14, 1, 5. 460, somewhere around that, right? So In length, it's 430. In breadth, we can say it's 460 centimeters. Right, I think I need to have the gains higher on my mic, or it doesn't, like, the whisper flow just doesn't hear efficiently if you do not have high gains on your mic or something. So yeah, I can't solve that. I live in Rajasthan, so go ahead and try to find out the temperature that is, like, yeah, and how much time it will take, yeah, like, yeah, to cool my room, and at what temperature it would cool efficiently, and make it so that, like, you know, it affects my ideal, like, you know, and keeps my room at a ideal temperature so that my ideal body temperature is maintained. Body temperature is maintained. And it's afternoon, it's 1:30 p.m. Right. So yeah, look up the what's weather at 1:30. I live in Bhilwara, Rajasthan. Right. Yeah. So, oh yeah. Okay. Could you maybe I can use Google Scan to know. Right, what specific information would I need about my AC? Got it. I think we can scan it pretty efficiently, guys. I think we need a better picture. Fuck it. Yeah, I think, guys, like, I really think that we would be able to calculate it, even if ChatGPT kind of like resists this. I mean, I'm not a Havak engineer. I think I will only understand. I need to get information from my dad. I'm not able to find it from Google search. I'm gonna come back with a call with my dad and also by peeing. So, guys, according to this bitch, I mean, Gemini, let's just see which bitch is actually true or correct or more correct here. But I think like these AIs have this habit of yielding from their reasoning a lot of time. But this time the problem is ChatGPT just wasn't yielding at all for some reason. I don't know why. Right, and that's like okay, such a wrong message from a girlfriend to message me back. Yeah, she's kind of getting obsessed these days. But as I was saying, yeah. So the thing is like I live in like yeah I give it like information. Oh, it's Laura, right? So yeah, transparency doesn't matter even if you know everything about me and what I do in a day. Yeah, you guys can know where I fucking live. I never try to hide it in the first place. As for the remaining, I'm a 18-year-old dropout from like I've never completed high school, and yeah. So yeah, once again, back to the point that we are here is that like yeah, you can see I live in Bhilwara, Rajasthan, stuff like that. But as for that, and the AC I use is belongs to a Daikin company from Japan, if you know it, and it's like 1.5 ton AC, right? So this is the on the information. Do you need any more information? I don't think so. You need any more information. So try to find out. Like yeah, you can go online, right? And like yeah, to get some data of what the local temperature is, through Google's API or something, and try to find out the what do you think is the most optimal like yeah the optimal like yeah the room temperature I would need, like yeah, like whether it's 24, 25, 30, 31, whatever, right? And my gender is male, right? And my age is 18, yeah, and I'm about to get 19, but yeah, if it gets it right, if it gets it right, like if it gets it right, it should be 26 to 27, right? We have given it every information that it needs, right? If it gets it right, that means the system is working, and you definitely need Monday 38 degrees Celsius, low perception high. This is the exact material data needed to test the core operational framework system D. Then Rajasthan Itna, we have the concrete physics puzzle temporarily. Temporary external temperature, real feel of due to intense solar radiation. In late June, the building exterior envelope is experiencing maximum thermal load, even if the room thermal layer is coolly evolves for observing radiant heat acting massive thermal batteries. 18, 16, roughly, you calculate body surface area as itna sitting down your metabolic heat generate apply itna watts of continuous thermal output that your body must reject into the room to maintain your thermal equilibrium. Despite the spatial asset system C room disturbances itna meters, assuming a standard ceiling height of 3 meters. Assuming this standard ceiling, length, breadth, and height. How the fuck I can't? Man, that literally fucks up the calculation, guys. That literally we're not gonna complete, but that literally fucks up our calculations because guys, I think we need to kind of like calculate the ceiling height. Oh fuck, what I'm doing? Yeah, we need to calculate the ceiling height. Let's do that. All right. How can I calculate it? All of this for a fucking business. All of this is for a fucking business. And trust me, I have no experience in air conditioners. I have no experience in air conditioner economy. No experience at all. This is how you build business. You don't need experiences. You just fucking find out something that works, and you go with it because you know the distribution of the kind of like would work, and it has a big market, and distribution is not impossible, and it's something that you can solve with your lame ass intelligence or something. I suppose if I'm thinking right, that's like a 3 feet. All right, now I got some basic information from there. I can build. So here till we have here, I think we have 3 feet, and I destroyed like the information 8 feet. Right. Why? What? This standard ceiling of what? What does that take as a standard feeling? Assuming standard ceiling of 3 meters, that's 8 feet. Right. And then if you take the bat down too, like that would be somewhere around here. So that's like what is fucking that? That's like 5 feet. No. We already got our 8 feet, but we just need to kind of like get it done here. So that's like here we have like how much feet? 1, 2, okay, 2 feet. So that's like 10 feet. and 1 feet is like 30 centimeters. So 10 is like 300 centimeters, which is like 3 meter approximate. Oh yeah, it kind of like is close to. I may say there would be like 3.5, but it never reaches like, yeah, or maybe like it says not 2.5. Maybe it will like slightly be more or less, but that's pretty much approximate height for the room is. 10 AC adjusting to the standard, like, you know, it possesses cooling capacity of roughly 5,000 watts. To standard baseline comfort temperature like itna. System logical 5. Why? Because the meat food itna. Because those solid surfaces are radiating heat onto the skin, your body cannot lose its from activate setting cooling mechanic elaborating setting. Oh, it's the timer. So you must drop the room air temperature lower to force the heat to convention the air to pass friction. To cool the room efficiently without turning your floor into an uncomfortable ice block. 23.5 by dropping the ambient to 2, the air actually convection thread. No, right now we are not actually designing anything. We are just testing the systems, like system A, system B, system C, system D. Like we are just testing them, and then you come up like, yeah, you come up with like the ambient drop of air to 22 degrees Celsius, right? The air acts as a like, yeah. Actually, the point with this room is, okay. And let's say like what we are, Control Z actually, escape, Control Z, yeah. Yeah, so what, like how long what should, like, yeah, so now we need to also create an adaptive system. Right now we're just doing the testing of our systems, and if our calculations are right or not. We are just trying to test our mathematical part. That's it. ChatGPT. We are not actually creating any code right now or any prompt like that, okay? And it's not ChatGPT, it's first fucking Gemini. Yeah. No, yeah. And now what do you think? Like, okay, but the temperature should drop eventually. We cannot sustain the temperature at 22 because the room would get colder. So now, like, you know, and when it gets colder and the wall starts to get colder over time, now how do we calculate that? Because even if we start at 22, what happens over time is like the system needs to like decrease the temperature, right? So sorry, increase, I guess, increase the Celsius, like, you know, increase the temperature to somewhere about 20, like 23, maybe 28, maybe 29, something to actually like, yeah, and then it needs to constantly alter at the higher temperature to maintain that thing, because like getting the room cooled is kind of harder than getting it maintained, like, you know, that's the thing. So yeah, maintaining it requires much higher temperature, which is easier, I suppose. It shows 37 degree, but according, I need to get my mom and dad's room watch, maybe here, or maybe get a mimic of that watch up there. And I will say, why, Varric? I think I need a like right now I just need a watch with a perceptor, like, you know, humidity and like a temperature. I just need it. I just need a watch. Like in this build project that we are building, without a watch it's insanely harder to build, like literally insanely harder to build. Your intuition have bypassed the static trap that compresses standard commercial climate control. I define the distance between transit thermostat, the full down phase, and the steady state, the maintenance phase. If a system treats a room as unchanging, it creates an unstable shivering environment. A room is a dynamic thermal engine, whereas on the real-time initial focus. Yeah. So first of all, you calculate how much influence does the AC have on a room. So what are the components? How much watts? Like, okay, we are calculating everything in watts, right? We are converting everything in watts. I don't know why, but it feels like I'm a fucking entrepreneur or something, solving problems for like businesses or market. It feels so fucking awesome. Right. So I think it concluded everything in watts, right? Because it's better to like have like everything converts to watts. Okay, what is watts? I did study that in high school, right? Well, yeah. What is a unit of power defined by rate of energy generator consume? 1 watt is equal to 1 joule per second. Okay, that's like, okay. We don't need to even know that. We just need to know there's a certain number of heat there, and then like, the numbers kind of interacting. That physics part is going to be done by this bad boy here. Definitely, right? System logic will fail. Why? Because the mean radiant temperature MRT of your full and war 38 afternoon likely hover around at 9 at now. Because those solid surfaces are radiating heat onto your skin, your body cannot lose it. Oh yeah, I'm actually got scrolled it up, right? The overcooling. Yeah, but what I do realize is that the ideal temperature you predicted is 24 to 25 degrees Celsius, and like over time, and my ideal temperature is 26 to 27, right? In the afternoon and in the morning, right? That is my and the ideal temperature you predicted is different than mine. Well, the margin of error is not too much, which is like the good thing, but still, there's still some margin of error there. What do you think is the most likely the cases that must have causes those errors? No, I think the reason is like there's no ceiling fan, but I think the I think I think there's one big variables that you missed is like cooling effect, right? That accumulates over time. Because what I did realize about if I when I started living in this room about a year ago, at the starting of the month, it was extremely hot, extremely hot. Like let me be honest, like maybe this is something I'm just hallucinating. That's why I need feedback. But it was extremely hot. But over time, what happened? It didn't remain cold. Like it didn't remain hot. And what I think is because of accumulated coldness. Because I use AC about like a couple of hours every day. So I think the walls, like because when I touch the walls, they don't feel hot at all, right? Because it's like compared to my downstairs at my living room, which is just downstairs, right? Just exactly below with exactly same sunlight, but it's not like that yeah that hot. Sorry, it's like it's a lot more hot. My room is not that hot. It's a lot more horror, especially the walls. And that's what I think is like. And the AC runs for the entire night. AC runs for the entire morning. The only time it doesn't run is when 2 hours when I go for the gym, and 2 to 3 hours like in the afternoon. But that's not the peak. Like at the peak times at the night and at the at the early stage of the day, AC is continuously running all day long, right? Without a fan though. So that's what I think, and that's have been happening for months. Like yeah, every single day. I think that's another reason why it's like happening this way. This is a much more greater reason, I suppose. Let's let's try to find out the dimension of the downstairs, right? I mean, like yeah, for our multiple systems. We should I should go downstairs, open Gemini on my phone, and then once again I should guys get some data, right? I mean, it takes inputs, but yeah. Profound reality of structural thermodynamics. That standard single day climate model completely missed. Accumulated is scientifically verifying phenomena called multi-day thermal inertia saturated or substructure component. All night, all morning, day after day, you have fundamentally altered the boundary condition of your room compared to the rest of the house. Here's the exact physics breakdown. Concrete thermal battery. Mass and high heat capacity. They act like massive thermal sponges. Runs for just 1 hour. Turn off the deep heat trapped into. Because of this extended time frame, your cold air doesn't skim the surface, it penetrates deep the core of the concrete walls. Over months of daily cycle, you have effectively charged the structural model with a deep-seated deficit of heat. Living room comparison. You noted that downstairs living room, despite having the exact same sunlight exposure, feels slightly hotter, especially the walls. Is trying to enter from the outside. Uncontrolled afternoon baseline where the walls. But then again, the problem is that but then again, the problem is that but then again, the problem with that would be Gemini is that like once it kind of like because the room heats up again, so we do not just need like something called like we need to keep track of the rooms, right? Because the problem is like if it keeps tracks of like how much, like it needs to keep constantly track of how many times for how many hours has the AC been running or something, because like when the time it's not running, the room is getting heated up again, right? And like we need to also keep track of that. Okay, it's running on fan. A phone battery changes when plugged in but constantly leaks power when unplugged. Thermal state of change. No, actually, I don't want to do that. I mean, we still need to like, okay, what I want you to do right now is take like, explain all the systems. Like what the system A takes as inputs, what the system B takes as inputs, what the system T takes as input, and what the system D takes as inputs, and what the outputs they produce, and how those outputs are interconnected to them. Like entire explanation. And I think everything should be happening in watts, right? Like calculating the heat in watts, calculating the body heat, the room heat, the every heat in watts, I guess. So yeah, we would be using that as the like our normal currency. Uh-huh. Okay, it's time to eat some food. Yeah, I'm actually getting a lot closer. I mean, ChatGPT was hallucinating there, but with this, I mean, with 2 degrees of like we can reduce it to 1 degree, like one Celsius margin of error, and if it's that, like in whatever circumstances surroundings you're in, like it becomes surprisingly easy for the system to like work on half-ass data, but work on like the better the data you'll tell it, the better its performance would be, honestly. before seeing data years as opposed to people. All, yeah, clothing differs, activity differs, personal preferences. This is why I keep. Exactly. Not because they're perfect. That's why I always say I never said we'll never have a like fucking fuck you. I mean, fuck you. Like, how would you know if it's a kid, if it's an adult? The variation would change. That means the thing to find comfortable. Ah, fuck. Took it so long to understand. That's a reason. That is the only argument. How would you bootstrap it when it's a kid? Fucking bullshit. Suppose people. That's why systems. This hallucinate. This bitch hallucinate. They hallucinate so many times. Fucking stupid. But I guess that's my job to not let them hallucinate and direct you into the right direction. Suppose we built a weather room. I bet System B does. I also bet System B does a better job. Because now you just get these contexts and yeah. References often meet indirect inferences. That's impaired, but then it's prior. Yeah, throw from a preference prior, but ideal body temperature we predict, yeah. Beyond simpler gains. Yeah. It elevates this project from a standard start thermostat to pure thermal balancing engine. Temperature is merely symptom what represent the actual velocity of energy moving through space. Analogy, methodology, architecture, machinery into single unified watts. We can balance the cosmic checkbook of your like yeah, it's kind of like full of philosophizing. System A, biologic human heat production. The biological system A treats the body as not static but as an open thermodynamic system. Reference to consistent respiration. Your biology funds inputs gender, age, height, especially surface activity level, right? Resting and metabolic. Yeah, what conclusion? The system calculates your basal metabolic rate BMR. So to your correct state at rest, your body continuously generates a specific. What is basal metabolic rate? Okay. Let me start using this Gemini too. What is basal metabolic rate? Body needs to function while at rest. Okay. And then we can add on the top of this system, we can add another system that learns. But first, we need the initial bootstrap system, which can actually bootstrap basic prediction anywhere and improve its prediction over time. So we can have a prediction system that predicts, and then another system that actually gets data. So behavioral systems, and then we can have context switch and learning. So what it does on the basis of context, what you chose, it will be able to predict better in what future and what context people chose what, right? Or something like that. Stored in the air mass by remaining. What's to tell you exactly when you are limited data. Yeah, now it's really like, how many times have I switched since morning? At least 5 or 6 times. If I can just remove this bit here, like, yeah. System A Q met human what's out, system C AC extraction what's, and then mechanical defense biology. Solar system D leisure, system P dynamic control, dynamic air temperature, dynamic flow equilibrium. System this, system D completely updated. Mat A is the AC runs, the constructional battery charges up, Q leaks drop down to 0. Q meet. Okay, what was Q meet? I think this response is kind of cool, and we have to branch out. Niall Severick, why do we have to branch out? Because you cannot lose. Sometimes you cannot just like, we have to still branch again. So we have to like branch in a new chat. Maybe we'll create a notebook or a project out of this, but we still have to branch off a branch, right? You know, we need to branch, right? So we have no choice, but we need to branch. Yeah, I mean, we do need to branch, right? So this is a branch of a branch. This is branch 1. This is branch, yeah. I mean, what were we asking in system B or something? We need to ask like whether there's a direct sunlight coming to the room, whether there's like, yeah. Like, yeah, I need to predict it again. So now, like, yeah, I need to, like, yeah, I'm going downstairs for making another prediction, and let's see if it predicts right or wrong, right? And on that feedback, we can iterate more. So let's just see. I'm gonna live test it downstairs, right? So I have no choice. Like in this room, I just can't test it, guys. Like literally, I just can't test it. So I'll live test this downstairs. I'll come back in a couple of minutes, if not hours, right? And we have been working successfully. If you take remove 55 minutes for the 3 hours, today is like a long day, and I do need to eat. So I think, oh yeah, first I need to eat. I'll come back after eating and after testing the system that we have built it here, right? I'll come back. Actually, I think it's time to wind down for today. It's already 3 hours, and yeah, let's wind down for today. The reason is like because I need to actually. Or shall I wind down? like I can do the test by myself, and I think I would be taking a break for about an hour. All right. And after that, at somewhere about 3:30, I would come back to work, 3:30 to 4:30, and then that I have to go to gym, so I would be prepared. So I would be there for just 45 minutes. So, yeah, and then I'll start working in the afternoon at somewhere about at what time I would work. When I come back to gym, I would be free at 6:30. All right. So if my friend doesn't call me, but yeah, 6:30 to 7:30 to 8:30, somewhere about that time, I will be working again, and then I go for dinner, and then come back and then take a shower. So yeah, so it's like 5 to 6 hours of work day or something. Right. Yeah, that's exactly what I wanted to reach for the past couple of months. Like including gym, it's 8 hour work day. But yeah. Yeah. So I think 8 hours of work day, 10 hours of sleep. That's literally 18 hours, and then you have 6 hours left. Like 2 hours for eating food, shitting, taking baths. That means you have 4 hours left. After those 4 hours, there's something that you need to like 2 hours for your friends, family, something like that. So there's only 2 hours left, and then that we do iteration update, trying to find out what works, what doesn't work, trying to do new services, buy different things, buy like yeah, stuff like that. So those 2 hours of personal take notes, sometimes thinking about some XYZ stuff, have sex. Okay, I am virgin, so yeah, I never had sex, but you get the gist. Yeah, bye guys, by the way. Thank you for today watching, and yeah, love you. Like no one watches the stream, but to be honest, I just love streaming.